if you allow them to actually have a little bit of sub-pixel precision and apply that while interpreting it, it'll actually change which pixels light up when you draw that line. So he would interpolate that color brightness along the edge and push it down. But that didn't correspond to actually interpolating a color across quads. It just interpolated them downwards, which didn't actually make any sense, but it was fine. It looked great. And in Thief, we said, okay, here's the sound source. Where can the sound can come from these two different directions, but this one's the shorter direction, so we'll have it come from that. How much technical detail did we want to go into about texture mapping in the software rendered days?
A lot, I would say.
Okay, great.
Take me back to the time where you were starting to learn how to program. How did it look like back then? Computers world, like how did it all look like?
Yeah. So, I'm a pretty old person. I'm in my late 50s. So unlike some younger people who started programming really young, I didn't start programming until I was 12 or 13. So, uh, I went to a private high school where we had a mini computer with a bunch of terminals. So a mini computer was basically a mainframe, but small. So it was a shared computer that multiple people could use the way a mainframe was. If you know anything about that era, that's what mainframes were like. Um, but I'll just add some context for this. So this is talking 1980. Um, my brother went to a totally different school. He was a couple years older than me, and the weirdo old computer that they had, he was programming Fortran using punch cards.
Okay.
That wasn't the current technology exactly, but what do high schools have? They have some, old hand-me-down stuff. So he he did not have a good experience with computer programming. The system that I started with in high school in 7th grade was a HP mini computer that weirdly was called Timeshare Basic. So it was the main interface to it was the basic programming language, which was very unusual for mainframes and mini
Yeah.
computers. So yeah, I started learning basic at school and in 7th grade. And then my father got an itch to get a personal computer. I don't remember why. And so we bought an Atari 8-bit computer, um, which nobody else in the family ever used for anything other than playing computer games. And which then I started programming and, um,
Was it first the games or was it first the programming?
what's what?
Was first did you
Was
first try
first.
games? Yeah.
Gosh. I think I had already started programming at school. So I think when we got the computer, I'm sure I immediately sat down and played game because literally first was games. But I think, the playing with the programming it probably was pretty much in parallel.
Okay. Okay. Basic, I didn't try basic. But I've heard that this was an incredible experience in terms of learning the program because it was pretty much instant feedback. You did something showed up on the screen, and then you kind of got amazed how quickly you can do stuff.
And that's actually throughout my career been a thing, which is that doing anything with graphics is particularly nice because you get graphical feedback immediately. And there's just something so much nicer about that than writing a compiler that then I mean, that's what, which is great, but it's just the immediate feedback isn't quite as immediate.
Okay.
But yeah, no, basic was, it's an interpreted language. So you just, it's like having a Python top level or something. You can write code, but you can just, you can just type in a thing to execute as well. Um, so I mean, yeah, there's a whole thing about what programming those machines was like, but I don't know if that's particularly interesting. There were people in that era who were, not hobbyists. They were, you know, 18 years old or 17 years old and selling games. They were making games and selling games, and I never got anywhere that far into it in my teens. Like,
Okay.
I was not, like, making shippable quality games. What the games back then that were shippable were still pretty janky, but
Okay. So this was high school then, and then you went
yeah.
to university.
Yeah, um so in university, I didn't want to major in computer science because by the time because I'd been programming for 6 years, and so I pretty quickly decided that I already kind of knew everything. Like I mean, like you'd have to go through all this introductory stuff, and I could place out of some of it, but like it just wasn't clear there was that much I was going to learn from it because I was really good at it already. And look, obviously, I had more to learn, but I could learn by doing. And so in the first year, or like a lot of a lot of American universities, they have a liberal arts requirement, which is that you have to take a bunch of different subjects just to like learn about stuff. You have to take intro level, on a bunch of stuff. So I did some of that, and then I did more of that because I was like, well, I should pick something to major in other than computer science. And so then I started working towards a philosophy degree,
Mhm.
and uh and by the time I was done with college, I had met all the requirements for the philosophy degree, but I also met all the requirements for the comp sci degree because I went back to it. And I was planning on getting what's called a double degree, where I would actually get a degree in both. It's like a double major is the traditional thing in American universities when you do two majors at once. But a double degree is a little different in that they actually give you two separate degrees and you have to do more work to get it. Um,
Okay.
but, I didn't quite have enough credits to get both degrees, and I probably could have switched to a double major and gotten both, but by that time, I was burned out on philosophy. I thought it was all terrible and not worthwhile, so I just took the comp sci degree and left.
Okay, which one philosophers did you like?
So the philosophers that spoke to me the most were called the logical positivists, and they thought that most metaphysics as practiced, the most written metaphysics, was sheer poetry. Like,
Okay.
that it was meaningless, that, like, the entire effort of philosophy in metaphysics was silly. And they were in the 20s or something, the 1920s, and, they eventually failed. Like, people moved on from that idea, but that was the one that I was like, "Oh, that's working for me."
Okay. Okay. Then then you got through university, even though you didn't plan on getting the computer science major, you actually got the computer science
Yeah, I
degree.
don't like 3 or 4 years into it, because I went for 6 years. So, like, 3 or 4 years
Okay.
into it, I was like, "Oh, let me just do the comp sci thing." Um,
Okay.
and there were some things that I learned from that. Like, I took a computer science, a computer hardware course and learned some stuff about computer hardware that I probably wouldn't have learned for a long time without having done that. And I took a class with spatial data structures and learned some stuff about spatial data structures that it would have taken me a little bit, would have been probably harder to get good a grounding on it because like things like BSPs then became important later. So having a little bit of grounding in that kind of helped.
Okay. I read that you joined two people to work on printer software right after university.
Yeah. So yeah, to rewind, when I was a teenager, um, playing the video games on the computer and stuff, the thing that I kind of enjoyed a lot were the text adventures. In the US, the big ones were by Infocom, the people who made Zork. Um, and I really enjoyed those to the point of like, I want to do this. This is what I want to be when I grow up was sort of the attitude I had. And I played a whole bunch of those, played them with my mother. Uh, and then that company went out of business. Infocom was the company that made Zork. And I was like, "Oh, I guess, like, yeah, text adventures just aren't a thing as much anymore because the graphical games are taking off." And so I just kinda, like, stopped taking seriously the idea of being a game developer, and at the end of high school. Um, and at that point, I wasn't really playing graphical games. For the first couple years of college, like I had an IBM PC that didn't have graphics. It was just a text only or a monochrome screen or whatever. And so I wasn't really in the game world at all. So then in college, I started playing these text adventure online multi-user things called MUDs. And there were two kinds of MUDs. There were social MUDs where you basically hang out and chat. It's kind of like IRC or gosh, what's the modern equivalent of IRC? Uh, Discord.
Mhm.
Um, and and then there were combat MUDs, which were a little more like devoted to the uh hack and slash kind of D&D inspired experience that like CRPGs kind of had, but they were text-based still.
So
And I was on both of the go ahead.
who, how did it work then? If it was text based, but you have all sorts of
Yeah,
stats.
even well, so, like, it kinda shows you can kinda see the I haven't ever played World of Warcraft, but you kind of see a little bit of it in World of Warcraft. You would like just say "thump this thing," and you would just every 3 seconds automatically swing and
Okay.
attack that because you were over the network, and so it didn't make sense to like have you be suffered by like what your network connection was, and you didn't want to just be able to tap as fast as possible. So yeah, it was just something kind of like that. Um,
Okay.
so I was playing both of those kind of things, and uh one of the combat mud that I ended up playing on was called Wintermute, which gotta say this even though it doesn't matter at all, was run by 2 people whose handles were Myrex and Fred.
Okay.
And, uh, and it was an LP mud, which LP stood for Lars Pensier or something like that. Don't know how it's pronounced correctly, but that was just the name of the guy who made it. And, uh it had this very weird quirk, terrible game design idea, which is that you ranked up levels, and when you got to level 20, you became a wizard, and a wizard was able to create their own realm in the game.
Okay.
And so the problem is that, like, being good at the combat and ranking up to level 20 doesn't qualify you to be a programmer making levels in the game, and certainly you didn't necessarily have the right mental space to like be a player positive, like to that one of the things that happens in online games is you get jerks, and now you have a jerk becoming a wizard. It's not necessarily a great experience. Anyway, so I was just on the verge of becoming a wizard on this place, Wintermute, and these 2 guys that I had befriended, uh, whose nicknames on there were Raistlin and Lucifer, uh, I'm pretty sure it was Lucifer. Um, we decided that we wanted they had become a wizard and I was like 19th level or something, and we decided we wanted to run our own LP mud rather than be on that one because we wanted to be like a more player friend like put the player first more. Um, so we started our own LP mode. Gosh, this is such a long story, but it is getting to your
That's awesome.
question.
That's awesome.
So we started our own LP mud. The 2 of them were both students at Texas A&M University, which is just it's a university in Texas. It's in a small town in the middle of nowhere. Like Texas has these. It doesn't matter, and um, uh, and so we set up this LP mud. Uh, John, John Price was Raistlin, and I and this other guy, Lucifer, who's not the other John that was going to bring up in a second, were running it. And, we imported the work we had done, the levels we had created for that other for Wintermute, we imported them. And we asked the one of the 2 administrators, Fred, if he would come along and join us as a super administrator or whatever, and he kinda came along occasionally as like the favorite uncle He didn't really participate, and he only showed up once in a while, but it was, like, kinda nice to have him there, like, to have him sort of approving of it, because we liked the stuff he had done, the world those spaces he had created, and he agreed to let us have that as part of our starting, 'cause when you create a new LP mud, there's a starting area, but almost all the areas is stuff that's been created by the people who've gotten to level 20, and so when you start a new LP mud, it's very empty, and so we wanted to have a bunch of stuff to start it. So, um let's see, where are we in the story? Okay, right. So we started running this mud and it was a success. It was fine. And um gosh, I don't remember the order. And there was this other guy on there whose handle was Thra, who eventually became a wizard, who I'd become better friends with, than we're friends with than even the guys I was running the thing with. Um, and so he got a job working at this printer company in Texas, outside, in the town where Texas A&M was. And then he recruited Raceland, John Price, the other administrator, onto that company, and they still wanted more programmers. Uh, so then he recruited me. And I should one more little detail is that, you know, in C, you have malloc and free as the memory allocation strategy. Like,
Yes.
familiar with that? So LP Mud used a custom malloc and free. I don't know why, but it did have a custom malloc and free. You got to remember, this is the late 80s, early 90s. Like, we didn't have a lot of the good mallocs that people came up with later. So it had a custom malloc, and it was terrible. It would stop and basically effectively garbage collect, but it wasn't doing garbage collection, but it just would stop for 5 minutes once in a while because it was like going through and processing its free lists and merging empty space or something. So I went and I wrote a malloc just for LP Mud to replace that for us because I was like, "This is terrible, let me write a malloc." So this is one of the kinds of things I was doing while I was in college is I would write a malloc. Like, it was just like, "Yeah, okay, I'll write a malloc because, like, if this is terrible and I know mallocs don't need to be this bad." Uh, and I think we did actually share that out with other people, but the point is that, like, because I had done stuff like that, the guys I was working with knew I was a good programmer, and so that was why, even though they were all in Texas A&M, and when he was, like, recruiting for the printer company, he was recruiting people he knew in the area. He reached out to me and said, "Hey, do you wanna come work with us?" Um, so I did. I went to Texas for 2 years, and I worked at this printer company. Um So we didn't make printers. We made software for printers, and we made software for high-end printers. They were typically like film recorders, which means instead of 300 dots per inch, if you've heard that number for printers, it was 3,000 dots per inch. And we weren't writing printer driver software. We were writing the software that goes in the printer that effectively, there were 2 things that this software did, is it processed postscript. So the application on the PC would you would tell it it's a PostScript printer, and they would generate PostScript for the thing, which is, just a universal language for describing print jobs. And then but it's also a full language. And then, uh, so we would absorb that, process it, and generate graphics commands. And so and then the graphics commands would somehow get onto the print, onto the paper or the film or whatever. Um, so there's all this stuff about that I can talk about, but it's like, I
No,
don't know. It's like a
first of all, this was a great story, and the idea that these guys in these times, because now remote jobs are kind of more popular, but they will reach out the person across United States to get you like, hey, we didn't really meet in real life, but I've seen you program the stuff for our mod. Can you come over and work for us? This to me
yeah.
is quite crazy.
To be honest, it was a little more complicated than that. I decided to gloss over the details, which is they flew me down to interview, and then they were like, "Yeah, we're happy with that." But I went back to finish my degree. But
Okay.
while I was finishing my degree, they had me write like had me write a thing, and I think this is more than 30 years ago, so I think it was sort of an extended interview, like it was a test, kind of,
Yeah.
but I'm not positive. It might have just been that they wanted me to write it. Um, and so the job that I had there was implementing something that in uh, PostScript is called stroke path, which is just stroke is when you have a line and you want to draw it as a wide line.
Okay.
And the way that's implemented in the stuff that we had is that you turn like a little line segment into a filled rectangle that's rotated to represent the shape of the line. But then you have to like go around curves and you have to do all this stuff. And one of the things that you could do in PostScript, so you could put in PostScript, you would describe a path, and then, so the path is just, an arc and a line and a whatever, and it would be implicitly closed at the end or explicitly closed or whatever. But you could describe a path and say fill, and they would fill in the path. Or you could describe the path and say stroke, and it would draw an outline around the thing. The weird thing you could do in PostScript is you could say stroke path, and what that did is it generated a new path. So let, let me put it in a simpler terms. Remember, I said that the way we implement the stroke is by filling a bunch of little shapes. So stroke path said generate all those little shapes, but don't fill them. Just turn those into a path now. And so you say
Okay.
stroke path, and then you say fill, and you get the exact same thing as you would from get saying stroke. It's just
Okay.
a thing you could do. But weirdly, you could say stroke path and then stroke, which meant make all the little box outlines and then or your box shapes and then draw them as outlines so that I can look at your random printer
Ah,
and figure out how you do it. So we could sit there and like say stroke path stroke and see how other people do it. So anyway, the whole thing is that the stroke that I wrote was what their old system did is they, broke the thing like when you have a curve, you approximate the curve, it's a bunch of little lines. And it would approximate each of the little lines with its own little quad, to fill the thing. But then you have to deal with, like, you'll get gaps between them, so you have to do stuff, and I don't remember what they did in the old one. And the whole thing that I was trying to do in my new one is generate one big continuous filled shape, not lots of little boxes. So leave out all the extra intervening lines and just draw the outlines. And there were some edge cases where it's a little tricky, it'll overlap a little bit or whatever. Anyway, so the point was they asked me to do that. I don't know, remember why. I did do it. The end result of what you get from that is that you have a lot fewer line segments in that path.
yeah.
And so the fill operates faster when you're because you don't have all these extra line segments that are unnecessary. So it's like twice as fast to fill or something like that.
Okay. And this was all in C programming language.
That's correct. This is all in C.
Okay.
I did start doing some C++ at that company. But anyway, all right. So as that interview, they did that stroke. And then I went to Texas, and for 2 years I worked there. We were making so the way it works was PostScript is a Forth like language. It's a stack-based language. So I don't know if you've ever encountered Forth. Uh It's it's a language where you give a sequence of instructions, and the instructions are push a thing on the stack, push a thing on the stack, and
Okay.
then an operation that consumes things from the stack. So rather than saying operation and here are the parameters for it, it's parameters and here's the operation on it. Um, it's a thing that somebody tried. Forth was a big success for very small machines because it turned out there were ways to code it so that you could make everything very concise. So the geniuses at this company, slightly sarcastic, uh, who were all former grad students of Texas A&M, the guys who ran the company, uh, had decided to use Forth as their programming language for the PostScript interpreter. So, they consume this PostScript that's a stack-based language, and they figure, hey, we've got a stack in Forth that'll just like work really well. And of course, it's a terrible idea because you're like you have your postscript stack, and you'd really like your postscript stack to just be separate from your computation stack, but instead it's all intermingled. It was I think, a terrible idea. Um, and so they had run this company. There were the two main guys. One of them was this like dedicated software engineer doing the fourth thing. They made their own custom environment. Uh, yeah, I won't talk about that part too much. The language was called Fifth because, of course. And then they had their uh, low level wizard, and he wrote the graphics library in I think 68,000 assembly. Um, And that fourth language was written probably in 68,000, and fourth. Um, but also he made a custom piece of hardware because the whole thing was we were running at these really high resolutions, and you don't actually have that much detail in the stuff you're pushing down. Like, you're mostly training lead characters, and so the character at that resolution is, 50 pixels wide or something like that. You don't need a bitmap with every single pixel on and off. So we used run length compression to store, the runs, and so the graphics library would generate run lengths. So like, if your output display was uh, well, I think probably he had a limit of 32,000 or 64,000. So if your image was 60K by 60K, you would actually have 60,000 spans of run lengths to store that image. But then he had hardware that would, and at a very high rate, take in the spans and, um so the thing is that this is for, like, offset printing, which is the printing where they have 3 colors with dots, and the dots are, like, in different patterns. This is old tech that has been supplanted mostly now, but you still see some of this. So, the way that works is just that you draw a larger or smaller dot. Like, the dot spacing is fixed, and you make the dots larger or smaller depending on how bright you want that color to be. And so the hardware had a table of a circle, and like it got fed a span and a darkness, or for that color, and looked up in that table and decided whether it actually needed to draw it based on the dot shape. So the whole thing was, it took two streams of runs. One stream was graphics and one stream was characters, because it saved a lot of work for the graphics library to not have to merge those. So if the graphics library had to, when you had overlapping graphics and characters, the graphics library trying to manage these spans, it would just would have been a lot of work. So they were like, let's just have them be separate. And so you'll come in with these mix of graphics and text spans, and the hardware would merge those lists because they're sorted. So it's straightforward to merge, trivial to merge, and then go through the stop process to do the thing. Okay. So hardware wizard. And like, one of the things that in talking to this guy, he was like, "Oh, I hate software. Like, with hardware, I can just hook it up to a logic analyzer and a oscilloscope, and I can see exactly what it's doing. And software, I never have any idea." I mean, he was a young guy. He was like 28 or whatever, not like an old curmudgeon. But whereas we us software guys were like, "You're totally nuts." Hardware, it's like, "Oh, the if you get the voltage wrong, it just breaks." Whereas software is pure, it just is all digital, it always works. Like, so it was a fun, like, clash of cultures a little bit with that guy. But he was super, super brilliant, and he was a good coder because, like I said, he wrote the graphics, the first version of the graphics. So when we came in, they needed more people because they were starting to get these other projects, and they needed to get off the 68,000 because they actually were shipping 68,000 plug-in cards that plugged into the ISA slots or whatever the slots were then of an x86 CPU, so that they could run their 68,000 code because that was all they had. So, the first job that they were working on when I got there, that so then they got these younger guys, us, me, John, and John, and we were, one of the first things we did was, uh, write a graphics layer in MIPS, and then the other thing we did was take the 4th byte code and compile it to C or something. God, I don't even remember. But there was some compilation step so that we could run the 4th postscript interpreter on something other than the 68,000. So it was some compiler thing. that I don't really remember. Anyway, the company was financially struggling the whole time that I was there. Um, just, wasn't quite ever selling enough to make up for the costs it had. And, um, I know where I wanted to go, but I'm trying to think if there was some other step I wanted first. Uh, Financially struggling. What was the point of saying they were financially struggling? Oh, so, so what ended up happening was PostScript, Adobe is the creators of PostScript. So Adobe had come out with a new version of PostScript called PostScript Level 2 that added a whole bunch of new stuff, and the graphics subsystem was different, and we obviously needed to move on to it, but we were very busy just trying to satisfy the contracts that we had for these various things because we were trying to port to the MIPS, and then we were trying to port to Next boxes for a crazy, crazy laser uh, thing. Like we did some Objective C actually, and because I think that's what the Next actually, I think that's where Objective C started was on the Next, not on the Mac, I think. But because Next was the company that Steve Jobs had started, if I remember correctly, while he was kicked out of Apple
Yeah.
back in the day. Anyway, so what happened was everybody else kept doing that, and they put me onto the level 2 project. So I was the only person on the level 2 project. I had to write a PostScript interpreter, and I think I wrote the graphics backend. I mean, I didn't finish it because we went under, but I was working on it, and I was the only person working on it, and it was all in C++.
Okay.
So I was writing a PostScript interpreter and yeah, so a PostScript interpreter and I believe the graphics engine for it, which still probably was span based. I don't remember the details now.
Okay. When you look back on this job, did you like it?
Uh, oh gosh, I just remembered to tell the other thing, different thing I worked on. But yeah, I gotta tell you this story just because.
Okay. Okay.
Um, one of the, I think probably just because they wanted money, so they would accept random contracts. So a random contract we got was uh a process I ended up writing a simulator for a processor that somebody was designing. I think this was an era where, like, Java bytecode was a thing, and so I think that the chip ended up getting repurposed to try to run Java, but at the time I was working on it, it was sort of fourth directed or something. But anyway, it was this crazy processor that, like, would consume 4 bytes at a time, and then the 4 bytes would be like fourth-like instructions. Because I remember I said fourth was compact. So you could have 1 byte instructions do meaningful work in a way that most, microprocessors of that era, you would have an instruction, but then it would read another byte or 2 out of the instruction stream to tell it which registers to operate on or some
Okay.
other information, like the x86 is still like that. Like, there are some instructions that only take 1 byte because they don't need any extra information. But so this was a language that was designed to be fourth based because that way, since everything's already on the stack, you don't have to specify registers. So it was like, because of the trade-offs of memory speed and stuff like that, this was some guy was trying to get a crazy design that like could run forth like stuff fast or whatever. So for some reason I ended up being the person writing a simulator for this. It was very weird language, so it would load 4 bytes at a time. Maybe it had a 32-bit bus, I don't know, and then execute each of those bytes separately. And then if one of them did need some data, it would be in the next 4 bytes. Crazy, crazy design. Like I said, I think it did actually go on. You can Google for it. It was called the Shaboom processor, SHBOOM. I think it did go on and get used for Java something. But anyway, so that was just, yes, it's another crazy, weird thing that I did is I wrote a simulator for a weird processor. Like, I just have done a lot of strange things.
This
Um,
this this
and
seems like a
feel free to cut any of these out. I will not feel bad if you cut any of these out.
no. I think these are great because First of all, this seems to me like first, if you can get your first job to do so much random but technical stuff, you learn so much.
Yeah,
And then you're like
absolutely.
ready to go. To me, like a lot of our current struggle is to find a place of work where you actually do stuff that is like interesting, low
Yeah.
level, it's very difficult. And here you're saying that's like in the span of 2 years, you've done so many crazy stuff right after university.
Yeah.
It
Yeah.
it
So
seems
your
great.
question was what was like was it fun or whatever? Yeah. And the answer is absolutely it was fun. Um, and I did learn a lot of things and I made some mistakes. I made some really bad mistakes, but I also did some good work. When the basically the first day I started, um, they were having a problem because everything was a little janky. Like their whole design wasn't 100%. So it turns out, remember I said that they could merge graphics and text streams, so
Yes.
they could, so when you drew, if you put down graphics, because normally what would happen is you draw a box and then you put text over it, something like that. And so it was just way cleaner if the text spans just didn't have to worry about what color the box was behind it. Usually the box would just be one color and it wouldn't matter, but you could have out the gradient. You could have an image, like you could have drawn a shape. So it's possible. So it was nice. But the system didn't have like a Z buffer. So all it could do was text in front of graphics. The
Oh.
hardware output system. All it understood was there were 2 layers that it could merge, and it would merge one on top of the other, and that was all it could do because it's a very simple piece of hardware. So what happened is they got back, like, I don't know why they hadn't addressed this, but the person who they were making the software for their weird film recorder or whatever it was, came back and said, "Oh, my customer has this problem. This thing doesn't print correctly." And the answer is, oh, they put down some text and then totally covered it with graphics. And because like they didn't need it or whatever, but rather than deleting the text, they had just covered it over. And the software just went ahead and drew the text on top of the thing. How they had shipped this with that kind of jankiness, I don't understand. But they were like, "Okay, clearly what we need to do is when we draw graphics, we need to go through and find out if it's covering over text, and if it is, we have to turn the text into graphics." Like, which is totally tractable. Like, they could just merge the text layers. They just needed to know if they need to do it and do it as rarely as possible. So they were like, well, what it boils down to is that we have a rectangle intersection problem. We want to know anytime a graphics rectangle or even a text rectangle, but people didn't normally like you could understand that like if you're making a brochure or anything, you wouldn't normally ever put text over text. Like it's just not visually appealing. So that's why they kind of got away with it. But they're like, we need to do a thing where anytime we put graphics in, we find any text that it overlaps and turn that text back into graphics so that we can do that in the software side and the layering works correctly. And like I said, they could do that. They had the code to do that. But they wanted to, yeah, I'm just repeating myself. They wanted to do that only if it was necessary. And so they needed to efficiently find that. And they effectively needed to efficiently find overlapping rectangles, and I had taken the spatial data structures class, and one of the things that we had done in that spatial data structures class is find intersecting rectangles. Like, there was a standard algorithm for it, plain sweep, it's order n log n, and I was like, and they said this, and I said, "Oh, there's a solution to that, it's order n log n, we can just implement it." And, so it was a good thing that I took the college classes because I did, like, literally the second day I was there or whatever, uh, use that.
Yeah. And then overlapping rectangles will be super useful for all the collisions and 2D stuff.
Yeah, although, of course, I never actually had any use for that myself ever again, but it was still but there is that same idea, like, broad phase collision detection, is what it's normally called.
Yeah. No, now, is there anything left on the printer side of things before we move on to Looking Glass?
There is, but I can't remember what it was. Um, oh, so, just to set up, I just this is the we're never gonna talk about John Price and John Davis again, so I wanna wrap up their story here.
Okay.
Um, so, oh, yeah, 'cause you actually had this as a topic, which was the fact that the 3 of us in our spare time, what were we doing instead of what we were doing for the company? So, there were 2 things we did in our spare time. One thing that we did is we played a bunch of PC games. So remember I said I had gotten out of playing PC games in college. Like I had played Rogue, like which is like a literal old Rogue, which is a text display. Um, and so in those 2 years that I was at that company, we played I'm sure we played a few other things, but the things I remember playing and what I mean by we played is we paid for them together because we were poor. It was my first job out of college, and it was a struggling company, so they didn't pay a lot. So um, often we bought them together. We played them at work on the fastest work computer. So I played Wing Commander 2, I played Ultima 7, and I played Ultima Underworld, which was Looking
Nice.
Glass's game. And and Ultima Underworld 2, I think. And, um, that was suddenly like and all of those games were by Origin, um, but published by Origin. And they were by Origin or they were by Looking Glass. But that was a kind of a coincidence. Like that was just the games we were interested in. Oh, and also X-Wing and TIE Fighter, whichever one was out at that time. So that was the only non-Origin game. Um, yeah, I don't think I played any adventure games or anything. So that was one thing that we did. And that got me like kind of back exposed to modern like of the era video games. But then the other thing that we did is, we formed effectively, it's a lot like what you hear about like a school of art where a bunch of artists have formed a little community and are all kind of doing work at the same time and somehow influencing each other. So like we were trying to write code to do 3D graphics, mostly 3D graphics. And we were kind of competing with each other, like who can make the most polygons per second kind of thing. Um, and we were very influenced by Michael Abrash. I don't know if you've heard of him. He's
Of
pretty
course.
famous.
Of
Okay,
course.
I don't
Of
know if he's
course.
still famous now. That's the thing. So, but he had done a bunch of columns in a magazine called Dr. Dobbs about Mode X and about 3D graphics, and we had kind of used some of those magazines because they had them at work for some reason, and because we were going to buy them ourselves. But we looked at those and used the ideas from them and came up with improvements and kinda competed with each other to some extent, which kind of amplified things. We also worked on, like, some text adventure stuff. We thought about, could we make because we ran this other LP mud that we were talking about. We were like, "Could we make a commercial text adventure mug thing?" And there were some, but yeah, and we kind of toyed with it, and I started developing a system for it, like a whole interpreted language with a compiler and an interpreter and all that stuff. But y we didn't end up pursuing that. But we did these graphics things. And then, at the same time as all of that, I'd have to look up online what it was. I didn't think to do this research. I did do a bunch of research, by the way, like digging up these old games that are old demos that I wrote. But, sometime during that 2 years, the guy who uh, we had brought in as our uncle, on the LP Mud, the favorite uncle, Fred. Fred's actual name was Tim Kaine. And Tim
Oh,
Kaine is
really?
well known in the community right now because of his YouTube channel, but he went on to make Fallout. But at the time, what he went on to do was make a game called Bard's Tale Construction Set. That was how he entered the game industry. And we knew he had done that. And we were like, oh, you can just get into the game industry. So although that
Nice.
game is not particularly important, the fact that he made it, like, something kinda opened, I think, opened all of our eyes to the fact that, "Oh, this was a legitimate path." And so that's how I wanted to wrap up talking about them, is that John Davis went in, uh, worked, then when the company shut down, they left a little before the company shut down, I stuck all the way to the end, but eventually John Davis went on, he worked on, Pilot Wings on the Nintendo 64, and then he went to, uh, the Call of Duty company, whoever that is.
Activision.
Well,
Activision. It's now. Yeah.
it's, um, I can't remember the specific company, the name is escaping me. Uh, uh, they then switched to making, oh,
In
Infinity Ward.
Infinity Ward. Yeah.
So he eventually went to Infinity Ward. And then John Price, the other, guy who's doing the 3D graphics with me, I think John Davis didn't really actually do the 3D, but he was in the group, and it felt like he was part of that stuff. But John Price went on to do, he did a Star Trek game. He did a couple things, I don't remember now what. We could look it up on Moby Games, but, um the point was is that I think it was a lot like one of those art schools, in that because all of us were there feeding into each other, and we got that example of Tim Kaine, which, we didn't know he was going to become Tim Kaine. He hadn't done Fallout yet, right? Like, we had liked the work he had done in the level designs he had done for the LP Mud, and thought he had a good attitude towards, player, supporting, like, being a player positive. I keep mentioning that, and I'm not really explaining what I mean by that, but it's just, not being a dick to your players, basically. So, so that combination of things, like, somehow all 3 of us went into the game industry totally independently. We didn't use contacts from each other or anything, just we all independently, and didn't even necessarily know the others were going into the game industry, but we did all go in eventually.
Nice.
I think I went first, actually, but, um, anyway, so
Okay.
yeah, so that's what I wanted to wrap up about that.
Okay. So before we dive into Looking Glass, I need to
Yeah.
mention something. You were talking that you were playing text adventures, and then you went into Ultima, but you didn't play the graphical adventures, the Sierra,
I did
King's
later.
Quests, and
I did later, but yeah, that wasn't like, that was the thing. I just missed out on the graphics during that era. And so then when I was in that period, 92 to 94, I didn't even look at those. We just played
okay.
the more simulation-y games.
Okay. Okay. I need to highlight the storytelling marvel you've done with like introducing Fred. Fred is the character.
Ye
Fred. And Fred showed up like then. And then he stopped showing up in the story. And by the way, Fred was Tim Kaine who worked on the Fallout. This was super cool. Didn't
I
expect that.
I did plan it. Look, I didn't plan, I don't have a script, but I did, like, I did write down a list of things I wanted to mention, and, like, yeah. So, yeah,
Okay.
that wasn't a lot.
All right. So now Looking Glass Studios. You're
Yeah.
moving again from Texas, right?
So so the company was shutting down, and I was like, "Okay, let me see if I can get into the game industry." Oh, here's a whole thing I left out that's not very important, but so so I went to a private high school, and everybody, it was a very small school, and everyone was bound for college. Like, it was a very, like, intellectual, like, everybody was, relatively smart, and I don't know why, but for some reason, they publicly posted our SAT scores, which are the scores you get for,
Yeah.
uh, for college applications. They just rank your ability. There's a verbal and a math. And I was known as a math in high school. I was known as a math person, a science kind of person. And so everybody expected me to do well on math and not do well on verbal. And uh, for some reason, they got publicly posted, and so both my peers, the other students, and my teachers, most of my teachers, were pretty surprised to see that I had equal scores on verbal and math. And in fact, literally equal, even though the averages normally math was higher than verbal. So I was
Okay.
Proportionally, verbal was higher than math and something. Anyway, so the point of all that is that I did have interests outside of programming and math. I just like I'm so good at programming that it just didn't make sense, and so that's like why I tried philosophy, But so uh, during college, I participated in Usenet, couple forums. Like I guess I paid a little attention to. Oh, of course we played Doom. Like and when I was talking about what games we played, yes, of course we played Doom. I, um, but so I look at those news groups a little, and I looked at the text adventure news groups a little, but I think the main news group I was on was a group called Talk.Bizarre, which basically was just a forum for weird writing. People would just think of weird ways to write things that weren't necessarily stories even. They were just, it's weird writing. And I kind of like worked in that space for a while. So I was doing very small amount of weird writing. And so I've always had some interest in writing or whatever. I'm just really good at programming, so it doesn't make sense to pursue it at all. So I didn't set that one up in advance like I should have. So when the company shut down and I started thinking, well, maybe I should go into the game industry, like Tim Kaine did it. So, uh, I played all these Origin games. Origin was based in Texas and I was in Texas. So I was like, maybe I should try to get a job at Origin. But I didn't know anybody at Origin. I didn't even know how to get a game in the game industry. But on Talk.Bizarre, one of the people who participated in that, one of the people who wrote random stuff, was someone who worked at Looking Glass and had worked on Underworld. It wasn't called Looking Glass then, but you know. So I emailed him, never tried to talk to him, but I'd seen him. He would have known me by name or whatever. Emailed him and said, "Hey, do you have any contacts for somebody I can talk to at Origin to see about getting a job?" And he said, and he replied with, "Why don't you apply here?" So,
Nice.
like,
Nice.
anytime anybody asks me, like, "How do you like get job? Like, hey, do you have advice for how to get a job?" I'm like, the guy I played one of the guys that I co-ran this LP mud with asked if I wanted a job, and then this guy I emailed asking about someone else's job asked if I wanted a job. Like, I can't give any useful advice for how do you get a job.
Yeah, I don't think that's a good strategy to ask for like a different company now. Like, you want to get into Google, it's like, let's ask Netflix for a contact to Google.
Um, So yeah, so I had asked him because obviously Origin published Looking Glass's games, so I assumed he would have contacts there. But he said, "Why don't you do that?" So they flew me up. They did an interview. Uh, the interview included, I don't really remember anything, but I very vaguely remember that they challenged me to uh, do broad phase collision detection on the whiteboard. So, which is, you have a whole bunch of things moving. You don't have to solve the exact details, but you want to know which ones are candidates for potential client. My solution did not involve the plane sweep rectangle algorithm, but, I muddled my way through it and my answer was good enough that they were happy with it and they offered me a job.
Okay. Okay. Was this common that the people flew interviewees
Yes,
over?
I think that was common if you were like at that kind of level of things of like serious programs. Like if you had to fly an intern, or something like that.
Okay.
Um, but for that kind of programming job, yeah. Like for
Okay.
other kinds of programming jobs, I don't know. And I don't know if they would have done that for a designer or, something else.
Okay.
Like I was slotting in as a relatively high proficiency technical programmer, and I don't know if a normal programmer would have gotten that treatment. I don't know if they knew how high proficiency I was, or I was just like, oh, he's good enough. Like I don't actually know what they were thinking at the time that they hired me. I mean,
Okay.
so to be clear, most of the Looking Glass programmers were MIT graduates. So the
Yeah.
their expectations of what normal was like, they may not have seen me as particularly high level. They may have just seen me as normal by their
Okay.
standards.
Okay. Yeah, and this was unlikely, right, for companies, game studios, that to be based in both Boston or near Boston, and to be comprised of like MIT graduates. I heard that this was really unlikely in the game
Well,
studios
I mean,
area.
Boston, Looking Glass, MIT is in Boston, so that's
Yes.
not unusual in that sense. But I don't think most MIT grads went into games. So yeah, I'm not aware of any other game companies that were like populated by MIT grads. Like
Okay.
even some of the designers were MIT grads. Like they weren't even I mean, like I think they had programming ability, but that's not what they did at Looking Glass. They were just designers.
Okay. Okay. And you came in when System Shock 2 was being developed, right?
System Shock 1 was just finishing up.
Ah,
Uh,
yeah.
so I actually made mini games for System Shock 1. Like it wasn't quite done when I got there. So I made some mini games for it and I play tested System Shock 1 a bunch, but I didn't contribute to the code other than the mini games.
Okay.
And then they developed the CD version of it, which ran at higher resolutions and had voice acted audio, and I made another mini game for it, but that was also my only contribution to that.
They developed CD version for it. So before it was with what version?
Floppy disk. So
Okay.
the first version came on floppy disk, came on 5 or 8 floppies or whatever it was, and then the CD version is the one everyone only ever
Okay.
thinks about because it had the voice acting. That was actually very normal. Like Wing Commander was similar. Wing Commander 2 had a separate voice pack add-on. So the
Ah,
Wing Commander
okay.
2 came on a whole bunch of floppies and then had a voice pack add-on, which were more fluff. And the problem is like shipping 8 floppies in a box was actually expensive cost of goods to have the 8 floppies. Like, the CD version was actually cheaper to make, and so more profitable, but not everyone had a CD drive yet, so
Yeah. Yeah. Like today it sounds ridiculous to have like a voice pack is something like an add-on for, additional
yeah,
additional voices. It's not like voices at all.
yeah.
Okay.
Well, and in fact, I was watching a retrospective about one of the Ultimas, and apparently it was like that for I don't know which one was Ultima 5 or 6, that they had a couple voice lines in the main release, and then there was a voice pack that added more voices, but not everything was voiced because the Ultimas just had too much text.
Okay. Uh, and the real development that you worked on was Terra Nova, right? Can you talk about it a little
Yeah,
bit?
so I started on Terra Nova. Well, I didn't start in Terra Nova. I started on a college basketball game that never shipped, so I'm
Okay.
happy to move on past that. Um, and I got put on Terra Nova. I was the third person to be the Terra Nova graphics engineer. And, Terra Nova was an outdoor squad combat simulator. It was a shoot 'em up, but it was a kind of a thinking man's shoot 'em up a little bit. It was definitely more shooty than normal Looking Glass games. I didn't do a lot of interesting technology on that, but I can talk about what I did do, and I do know some other things about it too, but none of the things to know is that we were trying to run that game in 4 or 8 megabytes of memory, I think, and the main map, was outdoors, and so we just used height fields, which are just, grid of heights, and so the main map was 512 by 512 because we wanted a big space. I mean, they had done all of this development before I got there, and then they had a lower res extended map past that, but because it was lower res, it was only 256 by 256 or something like that. But so just being 512 by 512, well, you have to store a height, which is, I think, more than a byte. I do not remember how big the maps were exactly, but you had a height and you wanted some precision. So I think it was more than a byte. What texture went in that tile? So like the map stored both information about the square and information about the vertex as like kind of both in the same spot. So it was, one of like 64 textures, the height, the light level, so a couple things. So it was like maybe 2 or 4 bytes, probably 4, maybe 3. but it probably is 4. And so if you do the math, 512 by 512 by 4, that's already 1 megabyte. And we were trying to run it at 4 megabytes, and you had to have all the graphics texture data and all this other stuff. So we were already like pretty aggressively pushing the storage on that thing. Um, so that's just to like give you some like
Yeah.
there's no point to that. Like that was just to give you some
Okay.
sense of the kind of thing we're working in.
Yeah.
Um,
You get to
so
you get
go
to
ahead.
appreciate, today's standards for, or like how much stuff you have at your disposal, how much resources you have when you just do this. Like at this point, it's ridiculous to me to think about in these terms, to have like I want to do something that is outdoor map, but I only have 4 megabytes of memory for
Yeah,
everything, and I'm
yeah,
like,
yeah. No,
okay,
it was crazy. So
we can because like you've done so much stuff, we're not going to be able to talk about like everything in detail, so we can skip past until thief game comes to the
there's some
stage.
interesting stuff about Terra Nova though, but I don't know how to get to it without just talking about so much. Um, so here's the thing. You have to understand, yeah, this is a fine place setting. So one thing to understand is that Looking Glass was not like id Software in terms of the games we made. We made more sophisticated, and this is not something the id Software this is not something John Carmack or John Romero would disagree with. We made more sophisticated thinking man's games, and they made more action shooting games that were simpler. And so one of the kind of a frustration, but I accepted it because I was happy that I liked Looking Glass's games. I enjoyed Ultima Underworld, like so I liked it. But it was a little bit of a unsatisfying thing as a graphics programmer trying to compete with John Carmack or whatever, that he could make a graphics engine and they would tailor the game around the graphics engine in some sense and show off the graphics engine and make it really good. And I used to talk about the fact that in an ideal world, we would be spending 90% of our CPU time pushing pixels to the screen because we were trying to get frame rates of like 20 frames per second, at a low resolution. Like that was all we could get out of those slow computers back then. So the problem is at Looking Glass, we would get 80% or 75% being spent on pushing pixels because there was too much other stuff going on. So when you were drawing a big, complicated, detailed scene outdoors. Y okay, let me put it this way. Okay, texture mapping. Oh my god, do we wanna talk about texture mapping? It'll matter for people. Like, this is how much technical detail do we wanna go into about texture mapping in the software rendered days?
A lot, I would say.
Okay, great. Then we'll do it because I need to talk about it now to explain what Terra Nova was doing differently. So, okay, I'm grouping my thoughts here. What's the right organization for this? Well, we talked about Doom, so let's go rewind to Doom. So, Doom produced very high quality graphics in a way that Looking Glass did not. And what the traditional term for this is that it was subpixel and subtexel correct. And I can describe without going into technical detail what what that really means. And so here's the deal. Imagine you have the scene described in some way as polygons with vertex texture coordinates of the vertices or whatever. But so you have some scene and you have a camera and you want to render this tiny 320 by 200 view. So you cast, this is not how you implement it. This is talking about what you want the results to look like. So you cast a ray through the center of every pixel and you see where it lands in the scene. And you interpolate the texture coordinates from the corners of the thing to find the texture coordinate that it is. And you grab that texture and that's what you put for that pixel. That's what you want. It sounds obvious, like it's meant to sound obvious. It's meant to sound trivial and obvious. And Doom did that. Doom was rock solid, produced exactly what you wanted. But the way you do that even in Doom, Doom is a little complicated, and we don't have to talk about it, but but the traditional way of doing this is that you take your scene description with a polygon and you project it down to 2 dimensions. So now it looks like that. And you interpolate over the edges, the texture coordinates, and then you interpolate across a span while drawing these pixels. And you get to this one and you're like, okay, the texture UV or ST is this. You look up in the texture and you grab it. And you can definitely write that code so that you do that correctly and you get the exact same result as that raycasting result that we said is our true reference standard. And that is what modern GPUs do. But doing that requires a lot of math. And one thing that you could not do in computers of that era is multiply two numbers efficiently. Multiplying numbers was slow. Dividing numbers was even slower. So I will talk about division. It's very important to texture mapping. We'll talk about that later when we talk about Thief. But uh, one thing that you saw, like the PlayStation did this, is that it wasn't perspective correct. It just interpolated in screen space these coordinates, and that was a little messy and sloppy. But even that, the thing that happens is that you have projected your vertices onto your screen. You know, you've said, here's where they are in 3D space, here's where they are in 2D space on the screen, but they're at fractional positions. Like
Yeah.
the corner didn't land at 3,2. It landed at 3.175, comma 2. Blah, blah, blah. That is being sub-pixel correct if you take that into account while you're processing things. So what happens is when you draw like a line between two vertices, and it's pixelated line, if you allow them to actually have a little bit of sub-pixel precision and apply that while interpreting it, it'll actually change which pixels light up when you draw that line. And that allows you, for example, to move the line very smoothly and continuously. But if you snap them to integers, it's just going to trick along and look a little jerky.
Okay.
And all of the Looking Glass code was not sub-pixel correct. It would just snap the things to the integer coordinates. And when you're running at 10 or 20 frames per second, it's not as obvious. Once you're like super smooth and you're like, you're not, your game is very Doom-like, or whatever, it's a lot more obvious, but it was still an issue in those Looking Glass games. And there are various reasons why Doom was able to do it, but some of it was that like we just didn't know better. Like part of the reasons why the Looking Glass games before Thief didn't get this right was because we just didn't understand that stuff. That was not like, like the Mike Abrash things that we were talking about. I don't think he even did texturing, or he did texturing very late, didn't talk about it very much. So all of that stuff is very expensive. Doing to get to the point of my 90% thing is that um when you want to draw an outdoor scene with this big detailed grid, that's very expensive. And it's not expensive because of the pixels, because the number of pixels you have to draw is about the same. Maybe there's a little bit of, up and down, causing some extra pixels. The problem is that you're trying to draw so many edges. But the problem with edges is that they require divides because the slope, you have to measure like how the things are changing with the slope. So Terra Nova wanted to draw this big grid. It got coarser as you went away, but basically, when I got there, it would draw like basically rings. And remember that thing I said about the postscript stroke where you had to draw little quads. They
Yeah.
they were actually
Yeah.
overlapping in that. So it's kind of the same thing. You're drawing all these they're non-overlapping, drawing all these little quads to draw a big outdoor scene. And you having to interpolate along all those edges. So there was a demo that came out in 92 or 93 or 94 called the Mars demo that was this amazing looking demo that you could only move forward. But what the guy did was he just connected the vertices at a given depth, and then drew the next set of vertices at the next depth, and the next set of vertices at the next depth. It's called a floating horizon. It's a standard thing. But by doing that and then filling downward from them. But you don't
Okay.
have to draw the downward edges. You only have to draw for every vertex. You're only drawing one, so there's 10 vertices here and you draw 9 edges connecting them. So it's basically one edge per vertex. Whereas if you're drawing a lot of quads, it's one quad per vertex, so it's 4 edges per vertex. So you're cutting down the number of edges you're doing by a factor of 4. And in the Mars demo, he was Gaussian shading, so he was computing a color brightness and interpolating it. So he would interpolate that color brightness along the edge and push it down. But that didn't correspond to actually interpolating a color across quads. It just interpolated them downwards, which didn't actually make any sense, but it was fine. It looked great. So there was this clever hack of like, hey, you can cut down the number of edges you need to do by a factor of 4. So Terra Nova basically did the same thing. It traced out these curves, but it was a texture mapped game. So you had to fill downward with texture. That whole trick was we drew a bunch of triangles or quads or polygons in the foreground up to some distance. But then starting at this distance, we started drawing what we called strips that were, like I was saying, tracing out circular arcs on the terrain. And as it traced out a circular arc, it was just drawing a floating horizon thing, and it was filled downward with random pixels from the texture corresponding to the map square. Random pixels,
Random.
just random. Because the whole thing was nobody was doing mip mapping in those days, and mip mapping is what you do to reduce the. If you don't mip map, you get noise because you start getting drastic aliasing artifacts. And so without mip mapping, you start seeing random pixels, effective, kind of semi-random pixels, moire patterns or other things. But because our ground textures were kind of noisy anyway, it was like good enough. It's a total hack, uh, and it would apply the lighting as well. It was a total hack, but it was like, it was like yeah, the games of the rest of the games of that era would draw, you know, uh, polygons out to a distance of 12 or whatever, and then have an incredible fog that just like everything just fogged out. And you would play games where you would see in the distance, because they would have some horizon bitmap, like, uh, mountains in the distance. And you see mountains in the distance, and you'd be moving closer and closer to them, and suddenly out of the fog covering the mountains would emerge
Yes.
a big hill, and which just doesn't make any sense because obviously if it was blocking the view of the anyway. So every other game like Magic Carpet and there was a Battle Zone game. They all did that, and Terra Nova just actually rendered out to the distance. And the compromise was that it did these crazy noise texture things. But you were also running at a really low res, so it was very obvious once you knew it, but it wasn't anyway. So that was all written before I got there. But the problem is that these big circular arcs involved looking at a table to figure out how do you step to walk at each distance, and that table referencing was costing memory lookups and taking time, and I switched it to traversing like a little like squares that were larger and larger as you went out. And if you do squares like that, you process more edges, like because the circles were taking diagonal steps, and so they could cut they could cut off some amount. So it was probably
Mhm.
like 1.4. So it's probably a square root of 2 factor or something like that. So it would do more edges, but because it was drawing straight lines, it didn't have to fetch memory, and it could like kind of do cumulative math and be more efficient. And the main reason I did it, I think, was it looked better to me because the circular arcs, every time you step forward, everything would change because you're not skipping, you're still visiting every vertex, but you're changing which ones you're connecting by edges as you move around. And so it just looked really weird. And so in the square shape thing, uh, the corners would jump as you moved forward. The thing would chip down, and now this edge is associated with an inner and an inner. Whatever. If it doesn't make
That,
sense, it's
uh,
too complicated to explain. But
yeah.
I,
I'm trying
if I
to
done, but
Okay, I'm trying to visualize this, but to me, if it's square, it should have looked a bit more weird than if it was circle, right?
On the edges, it was a little weirder because one of the things that happens is when you're drawing those edges, if the more an edge is perpendicular to the viewer, the better the effect is. So if you have the edges that are sort of parallel to the viewer, it does look a little worse. But our field of view wasn't that wide, and so like if you imagine the that you're rotated 45 degrees and you're looking at this shape, then it was fine.
Okay.
So there was definitely a worst case of looking absolutely straight on, but to me, it looked better and it was faster, even though we were processing more edges because it didn't have to do all that other processing. Uh,
Okay.
so yeah, so I see why I wanted to go into that. Like that's just, it's it's it was the crazy kind of stuff we would get up to in those days. But it made a huge difference. It was a game where you could see into the distance, but no other game could do. Didn't sell at all, but it was a nice technical achievement.
This is to me interesting. It seems like it's different now in terms of um back then games were a sort of if both marketed and sold around the idea of what is the technical feasibility, right? Like, oh, we managed to do X, and this was kind of a selling point, right? Now it's not. No, this technicality is no longer the case.
Well, so that would the so to be clear, there were games that didn't always push the technical envelope, but there were a lot of games like Ultima 7 was a technical marvel and Wing Commander 2 kind of. Um and like the X-Wing series was a whole series of like, well, the first game is flat shaded and then the second game is grow shaded and then the third game has textures. So you were always upgrading to keep up with the technology, but you weren't always necessarily leading edge on it. Doom was certainly a huge technical accomplishment, but then all the Doom clones were not technical accomplishments. They were just doing what Doom had already done. That was what we called them in the day, the other first person shooters.
Yeah,
But
yeah.
I kind of mean that narrow window of a couple of years after Doom when they were being made. Um, but that was definitely a phenomenon. It was definitely a phenomenon. You had these games that were pushing the edge. That it's kind of famously there was stuff like, these were DOS games, and in the DOS environment, until we got the DOS extenders, you only had 140K of memory, and then there was like expanded or extended memory that you could access with bank switching or something. I don't know the details, but uh the there was this whole thing in that era of setting up your config sys, which is a file that was read at startup, to try to minimize the amount of memory that was used by the DOS system so that when the game started, it had enough memory to run. There was this whole nightmare of that was always everyone was always pushing on that boundary of, "Oh, we get a couple more K?" And it would be this whole nightmare of trying to set up so your sound card could still work because you need your sound card drivers or whatever. I don't remember exactly. It was this whole crazy config sys thing. You can if you Google config sys, from that era, you'll get to see people
Okay.
talking about nightmare stories. But yeah,
Okay.
so it was so crazy back then. And yeah, and it was definitely a thing that was going on was that a certain level, certain kinds of games were definitely being sold on their technical accomplishments. I mean, but that's not that weird because even like 10 years ago, people were still talking about, oh, this game is like, Crisis looks amazing. Maybe that's more than 10 years at this point. But, there has been the graphics fidelity war has been a similar kind of a continuation of that, I think.
Yeah. So if we were to enter Thief, what would be the like? Can you take me into Looking Glass Studio and sort of conceptual model of thinking about Thief as a prototype? What were the ideas in terms of what the game should accomplish? What should it be?
The game or the graphics engine?
I mean both. Like
Okay.
what
It's
was
really different.
yeah, but
They're very different.
I don't know
Because like the
how much
game the game
technically.
took a very long time to figure out what it was, and I
Okay.
wasn't involved in it that much. So, but I can definitely talk about a lot about the graphics engine and a little about the game.
Okay.
Um, so let's see. I want to make sure I don't forget anything else. Terra Nova. Excuse me.
Was
I
it well, you make it sound like it's two separate things. Like, wasn't this sort of thought, to get, like, if you're making an open world game, then graphics should support the open world stuff, right? Like,
yeah.
it's almost as if like this is, you could do the renderer separately from the game itself and then swap from thief to like police work and it would work.
Do you mean in the sense that I just said of how we weren't writing the game around the engine, the way
Uh,
I was saying that id Software did? Like, is that sort of the direction you mean?
I just want to ask, like, is when you were thinking about Thief internally in Looking Glass Studios, was it more about like we want to do a game about a thief that will be very much stealing things, and they need to know what is the lighting aspects, and this is why you came up with a rendering technology? Or was this something different where you're like, we need to do this rendering technology, and this will, for example, be applicable in this type of gameplay, so maybe this, we should have like a game design that would feature this? What was the leading part of it?
Very complicated. The answer to that is very complicated, and I'm happy to talk about it.
Okay.
Um, I don't know if I'll get it all in the right order.
Okay.
So, gosh, I don't even know what order to tell it in. Maybe I should talk about the game first, and then we can go back to the
Okay.
graphics.
Okay.
So, you know, we had done we were doing 3 games in parallel. So, System Shock, Terra Nova, and Flight Unlimited. Flight Unlimited was another texture mapping outdoor game, but very different from Terra Nova. Um, and so the Terra Nova team wrapped, and I guess we started working on what became Thief. Gosh, I really don't remember the exact timing of it. Because one of the things that happened is I was always doing research. I was doing graphics research just as an extra thing. I would work, I don't know how many hours a day, but I don't know how many hours a day I would put into the actual job I was supposed to be doing, but I would also then put a few more hours into the other stuff. I was probably often there for 10 to 12 hours a day, but it was all self-motivated. Like I 100% agree that like, don't do that. You're getting exploited by your bosses. It's a bad idea. But if you own your own company, then you of course can do that. And I was a 27-year-old or whatever, however old I was, and I didn't have a family, and I was living in a house with a bunch of the other guys from this company, and, um, uh, I loved what I was doing. Like, I loved programming. I loved doing graphics research. If I was at home, I would have been doing the graphics research, so it didn't really the fact I was doing it at work, I was doing it for the company, so yeah, they're ripping me off, but, not it's really excuse me, the cough is just something I've had for 20 years. It's not a bad sign. Okay, anyway, so game. So, I think Doug Church probably pushed on the idea that he wanted to make a sword fighting game where you control the sword with your mouse directly in some way, even though the mouse is only 2D and a sword is 5D or something because you have position and orientation. So 6D, 5D. Um, but he wanted to like explore that idea. And so we were trying to come up with game ideas to pitch to the bosses. Um, and I honestly don't remember exactly how that process went, but eventually we ended up where we started pitching. We had like a what's we one of the phrase that comes to mind is a come to Jesus moment, which just means like you have to uh, it's kind of shit or get off the pot is another great phrase for that, which is just the idea that put your money where your mouth is. Like you gotta choose. You gotta come to the decision. They're a little more specific than that. But anyway, so we wanted to do this sword fighting game, and we had two pitches for what the game could be. One pitch was called Better Red Than Undead. And the pitch was that you would ally with communists who were fighting zombies. So a
Wow.
better red than dead.
Okay.
And the other pitch was called Dark Camelot, and it was a retelling of the King Arthur myth, but with everything subverted. So King Arthur is a villain. Uh, I can't remember any of the other details about it. Mordred is the hero or something. And um, but they were both sword fighting games. We hadn't done any prototyping or anything or maybe we'd done prototyping, but we didn't have anything that worked or was convincing about the sword fighting idea. But that was still what we were pursuing. Doug had a pitch of a thing he wanted to do. So one of the things that happened in the Ultima Underworlds was you could stop and have conversations with people, much like the Ultimas, and you could barter with them, but you could go through these conversation trees. And everybody at the company kind of felt like that was a letdown of the immersive sim experience because you stopped being in this 3D world and you switched to this other interface and you had this conversation and it wasn't real time anymore and it just like didn't feel like the right thing. And you could try to think about, could you do that in real time somehow? But instead, what they did in System Shock was they killed everyone off. It was a space station full of zombies. You had audio logs, which in the floppy version weren't audio logs, they were text logs. Um, and there were a few supposedly living characters. You would get an email or a message or whatever from somebody who is trapped on level 5 in this room, but by the time you got there, they'd be dead. So there were never any living characters in the game. It was just a email that pretended that they were alive, of course. Like System Shock 2 expanded on that by then actually having not cutscenes, but in-engine cutscenes of characters interacting, but they were behind a glass wall or something. So you couldn't interact with them, but you could see that they were alive. But anyway, so in System Shock, they said, okay, let's just end run around it by not having any living characters. We'll fake a couple living characters. So Doug's pitch for the sword fighting game was to have, gosh, I'm going into so much detail on this total tangent. Uh, so A, cut me off if you're gonna go stay up too late if from me
It's
telling all
fine.
these tangents. And B, again, if you cut it, I don't care. All right. Where was I? So Doug Church had this idea, sort of expanding on that of like, well, what do we do about these co-character things? I'm trying to remember what he called them. Gosh, I can't remember. There was some jargon term. We all had jargon terms for everything. But so the pitch was to have an off-screen character who was part of your team and contributing in some way. Like imagine to pick a totally different scenario, something that's easy to understand is, imagine a movie or something where there's a guy breaking into a facility, but he has comms, and on the comm is a hacker who's looking at the streams and giving him advice about how to get through
Yeah.
stuff. And now imagine you're the character in the game and you have the hacker voice and the hacker can unlock the door for you. That was the idea. I I don't remember how that was supposed to get instantiated in the sword fighting games, but there was this idea to say, can we get these characters who are now not in the 3D world, but they are having an effect in the 3D world, right? So you can see there was an attempt to like wrestle with this problem of like, how do we do this thing? And of course, then Half-Life came along and just put characters in the 3D world and like, they barely do anything, but it works. Like, right? Like Half-Life showed, oh, this is how you can do it. Anyway, Thief also, shipped a month later, but if they have, beat us to it. So that was where that game design kind of was. And so we pitched to upper management these two game designs, and they said, we don't like Better Red than Undead, do Dark Camelot, which was disappointing because I think almost all of us liked Better Red than Undead more. Dark Camelot just seemed kind of cliche. So Dark Camelot, I wasn't around for a lot of it when it morphed into the Thief game. I quit Looking Glass because I was frustrated with the direction the company was going. Like, I kind of pitched it as, oh, I want to get to do my graphics research and I don't get to do it enough. But I think I was more really frustrated with management. Like, kind of like that Better Red than Undead thing, but not like that specifically. But it was just like the company made lots of crazy choices. They got acquired by a random company that decided to try to get into games, and then we got spun back off because the company was financially struggling. Like, I don't want to second guess what they were doing, but I wasn't very thrilled with what the management was doing. So that was why I quit. And then I rejoined, and then I quit again, and then I rejoined again, and then the company went out of business. But so there was like a whole thing about my tension there, and it did mean I wasn't around for some of that thief discussion. But apparently what happened was they put in the stealthy stuff as one of the things they were doing, and the sword fighting just never came together. And so they eventually went, well, you know what? This stealthy stuff is working really well. By the way, well, okay, I'll come back to the by the way in a second. Um, this stealthy stuff is working really well. Let's just go for a thiefy game. I think Paul Nerath, the head of the company, I just complained about management, but I think he was the one pushing on that. So, which was clearly the right call. Um, it's funny because back in Terra Nova, you were playing these squad combat things, but you could send your squad mates off on their own missions. And you had these sensors because you're in a powered battle armor. So you're like super high tech and running around, and you have these maps, and you could have sensor pings and you could see where enemies were on the map from pretty far away. And I was like, if we just tweaked the AIs and gave them sensor radius that was smaller than the players, you could do like stealthy stuff. And I had pitched that long before we even thought about stealth in the thief thing. I was like, I think this game would be more fun if you could sneak around, because I was playtesting it. It was like kind of trying to sneak around them and they wouldn't do it. Like, they beeline towards me and I was like, they shouldn't know where I am. And I don't know. Anyway, so it's just kind of funny that like,
Came
um,
back.
yeah, okay, it did turn out to be the right thing, at least in that other game, which, I talked about the fact that I was also a hobbyist writer. This is the whole, I'm also a game designer. Um, but again, I'm so much better at the technology stuff that like that's where I tend to put my effort, is because I'm just such a good programmer and I'm not necessarily a great designer, but I do have some good ideas. Anyway, okay, so Thief ended up being a thieving game at the very end of the process, not at the beginning of the process. So
Okay.
it wasn't any direct impact of that on the graphics decisions. So now let's rewind and talk about how the graphics ended up where they ended up.
Okay. Okay.
The starting point for that is that we had Terra Nova, which was outdoors, and we had System Shock, which was indoors. And it was clear from like the Ultimas and all this other stuff that like being trapped in a dungeon was like really limiting. Like, it doesn't feel like in a traditional RPG if you're just trapped in a dungeon. Other people put out, the arena, the Bethesda, or yeah, I think it was Bethesda, the Skyrim people. They are very early games, like had big open spaces. Daggerfall was later, I think. But so we were thinking about that, and there was certainly like a subculture at the company that would have liked to have made an Underworld 3, an Ultima Underworld 3. Maybe not name, maybe it would just be our own game, but that would be in the spirit of the Ultima Underworlds. Now, I was all for that because I had really enjoyed Ultima Underworld. I liked immersive sims. I was okay with System Shock, but I kind of missed the like leveling up and some of the more RPG trappings. Um, so I was definitely enthusiastic about that idea. I'm not sure Doug Church was. I think he really wanted to move on conceptually and tackle different kinds of subjects. And he was a very important person in I, he knows better than me. I'm not saying I was right and he was wrong. Um, but he had a lot of influence because he was like employee number one or something like that. And I think he was one of the only non-MIT grads, but only because he quit MIT to start at Looking Glass. Like he just didn't finish his degree. Um, so uh where was I
So
with that?
we're starting the graphics part of Thief.
Yeah, but what was I saying? Why was I bringing up the Doug Church story? What was the Doug Church story? What was the
We're talking
oh
about
Underworld
yeah.
3? Yeah. So the thing that we all thought for Underworld 3 was that we needed the what we called the indoors outdoors engine. We needed an engine that could do indoor spaces and outdoor spaces. And as the rendering guru effectively at the company, I mean, I think I was at that point. We had other people doing rendering, but I was the person who was constantly doing graphics research. Like I had all these, I mean, they came later. The ones I have came later, but I was just always experimenting with stuff. Um, but oh my God, that's too much time to explain. I won't. So, um, so I decided to think about how to do indoor outdoor. And I thought about it and I just couldn't see any way to write a single renderer that could do good outdoor spaces and good indoor spaces. Like Unreal came along, uh, the Unreal Engine started life as a single game called Unreal. And one thing that people talk about with Unreal is it had outdoor spaces. Well, there's really big indoor spaces with like one of the things that happens once you make it really big is you like need to change your texture resolution, or there's various there's some stuff that you have to do that they did, but they were still very simple polygonal environments. It was clearly still indoors engine wise, just they had made big spaces. So we weren't thinking that. We were looking at Terra Nova and we were thinking, how do we do this kind of thing? And I couldn't think of any way to make a single engine that could do both. But I was aware there was this research by a guy named Seth Teller who had done a thesis on something that uh, visibility. It's a that involved portals and cells. So the idea was that you divide space up into these separate things called cells, and you put portals connecting them. And they're very coarse. They're like a whole room could be a cell, and the doorway is a portal. And the point of this is that it allows you to trace visibility through the environment and not draw all the stuff you can't see. So when you have a building and you're on this floor, you shouldn't have to draw anything on this floor. And because you have portals that lead up through a stairwell or whatever, you can see, oh, there's no line of sight to it. And so he had a thesis, a PhD or something on how to do this. And he did it both at runtime and uh, continuous at runtime and some pre-computation stuff. And uh, I had read some of that thesis or all of it or whatever, and I was like, well, maybe if we use portals and instead of just using them as a sort of coarse visibility abstraction, oh, can I see through it? If you actually have it like physically there and you can see through the portal into a different universe, it's a lot like what the game Portal does. Like effectively, you're seeing into could be anywhere. It is just through the other portal, but the technology supports it being anywhere. So I was like, well, if we could just make a system where we have two engines, an indoor engine and an outdoor engine, and then we have portals supported by both engines so that you can see from one into the other. That was my pitch. So I, wrote that up or whatever. And then I started working on trying to figure out how to make that happen, how to code it. And eventually I wrote an engine that was only an indoor engine and it used portals just to do visibility within the indoor space, because every indoor engine Looking Glass had done up to that point had actually been on a grid. System Shock 1 was on a grid and Underworld was on a grid. They had squared off walls and they could have like diagonal walls, but they were very limited. They couldn't do freeform spaces. You couldn't do rooms above rooms. You couldn't do a bunch of other things. And so I was like, hey, as a starting point, if I use portals, I can just make arbitrary spaces and we do know how to render them. You have to remember, in this era, we did not have Z buffers because we were doing software rendering. And doing a Z buffer was way too expensive in a software renderer, although Quake did do it. We'll talk about that. But um, so what you did was what's called Painter's algorithm, which is just that the idea is like if I put down a circle of blue paint and then I put a circle of red paint and they overlap, because I drew the red paint after the red paint looks like it's in front of the blue paint.
Yeah.
So it's a timing thing. You do them in this order, and that results in a depth. And it's a very obvious thing, like Photoshop layers. Like it's the obvious of that. But it just means that you have to draw everything in the right order. You draw everything back to front, and everything in front
Yeah.
draws on top of the other things and hides them. And so one of the problems that you had is you needed a way to draw back to front when you're drawing a weird arbitrary space. And the portals tell you what order you went through to see things, and then you can go backwards order from the portals and draw things in the reverse order and get uh that depth correct, that ordering correct. For the environment, there's some extra complexity for the objects, which is what I wrote the part of what I wrote the thing about. Anyway, it's a little bit of complexity because sometimes you can see the same thing through two different portal routes, and so you have to do a little more complicated sort to get that correctly. But as long as you never see cycles, that's the classic thing that depths that the like if you have overlapping fan blades, you can't actually draw those correctly with Painter's algorithm because the one is in front of the other is in front of the other is in front of the other. Like if you
Okay. Okay. Okay.
and we had smart people from MIT working at Looking Glass, so other people had already solved this when you had like an arbitrary 3D model like an airplane or something like that. You would run into this problem when you tried to draw it. And so the classic solution to this was that you would build a BSP tree uh, and use which side is the camera on of a plane in the BSP tree to decide what order to draw things in. The details are a little complicated, but you didn't need a BSP plane for every polygon. You just needed enough BSP planes to resolve the sort order for all visible directions. So you might have you might have 150 polygons and 3 planes in your BSP tree. Like it wasn't that expensive. So So the thing that I ended up with was a design for an indoor space that could do sort of arbitrary spaces. I had a demo of it and I showed it, and Warren Spector, who was the producer of System Shock and also Underworld and had done a bunch of other things at Origin, happened to be there and looked at it and said, "Ah, that's amazing. We should do 3D Joust." And of course, 3D, this is exactly like the Carmack, let's make the game around the engine because, he was just impressed to see like a thing and thought we should do something with it. And of course, we didn't ever do anything like that with it. But, that was his first impulse when he saw it. I just thought that was like amusing, like, okay. A, I'm pretty sure it was Warren Spector, and B, I'm pretty sure it was 3D Joust. But I could be wrong on all of these things, right? This is all 30 years ago. I could be conflating different stories. I could be, whatever. But this is my best estimate. Anyway, so I apologize to anyone who I say anything incorrect about throughout this thing. I'm doing my best. Um, so that's where that was. I had this sort of design for the thing.
Can
But
you
then the other
can you
go ahead.
can you so to make sure that I understand,
Absolutely.
an indoor engine where you have space divided in cells, and in any given moment you're in one cell, but you also can see through other cells, like through portals to other cells, into other cells. And these cells can be like non-uniform size. They can be anything. They are during the development like created, and they're linked together.
I believe so. This is very speculative on my part at this point, but I believe at that point what the engine was is I had hand written down numbers to build the level. Like I had no level editor, so I had just written down polygons. So I believe what it was that each cell, so within a cell, you didn't have any sorting, right? Like the sorting came from going through portals. So in a single cell, you didn't know how to sort it. And I wasn't like making a BSP tree for each cell or anything like that. So each cell had to be convex or concave, convex from the inside, whatever you want to call that. Like you couldn't have any protrusions or anything like that
Okay.
uh, with the engine in the state that it was. Now, it was clear like you could try to do things like add BSP trees. So what happens is you have a cell, which like is for example, is a room. I mean, it wasn't, I had made this really simple abstract geometry, but a classic example of this would be you have a room, then you have a doorway with a corridor leading to another room. So you make one room be a cell, make the corridor be a cell, make the other room be a cell, and then the portal is the exact shape of that doorway, like exactly that doorway, because you want to know exactly minimal. It has to be large enough that it's conservative, that you don't miss anything, and you want it to be as small as possible so you don't waste time drawing stuff that you don't need. So effectively, what you end up with is spaces connected by spaces, like the two rooms in the corridor, and then the portals are exactly just the intersection of those, if you
Okay.
know what I mean by the
Yeah.
2D intersection of the 3D surfaces.
Yeah.
Um, in the abstract, that's what you wanted. That's what you wanted it to be. You could use larger portals, and it would have worked, but it would have been less efficient. But anyway, so that's what I had. I had no way of making the levels, no idea what any of this was at that point. So, did that answer your follow-up?
Yes. Yes. Yeah.
Okay.
Yeah.
All
Yeah.
right. So we move on to the next phase. So I was on a mailing list with a bunch of other high level graphics developers from the game industry. So in one sense, it was like a secret mailing list that like, yeah, but in practice, it was because like if you went on Usenet, you'd have all these Yahoos who probably knew what they were talking about, but didn't. And if you made a public mailing list, you would get all these Yahoos who thought they knew what they were talking about. So it was a private mailing list so that we knew everybody actually knew what they were talking about. But it was a little weird to have a bunch of people in the same industry sharing information with each other, but not with anybody else. So I'm not going to name any names of anyone else who is on that mailing list in case they feel like that's maybe even though it was 30 years ago, like, maybe that seems or 25 years ago, maybe that seems a little, uh, offensive. I don't even know what the word is. Illegal? I don't know. I guess it wouldn't really be illegal, but anyway, so on that mailing list, I happened to learn a lot about how Quake worked. Um, so I knew that Quake was doing CSG, constructive solid geometry, to build their levels. And I thought that sounded interesting because the problem that you had, the way most people were building levels, Looking Glass had been doing these 2D grids, which really simplified building the levels. And Doom used a 2D editor as well, because it really just extracted heights. Um, Trying to do it in 3D, like most things were like, oh, grab a vertex and move a vertex, but now your polygon isn't planar. Um, oh my gosh, should we talk about non-planar polygons? Is that what we're talking about?
I would say maybe not for the sake of the story.
Yeah. Uh, I mean, it's a whole thing in software rendering, but okay, we'll leave it. Um, so um, CSG, constructive solid geometry, you put down well-defined shapes and infer the polygons from the shapes, and therefore your polygons are watertight. Remember, I said we really want these portals to be watertight, like matching to the geometry around them, and people don't mess with vertices. It's just, gosh, that sounds way better. And I tried to figure out how to do it, and I had a lot of trouble. I could not really figure it out. I like conceptual Java. I just couldn't figure out how to make it work, and posted to that list. And someone on that list who had some experience with doing it suggested a model for how you might do it, which is not actually how Quake did it, but was a useful model for what I was trying to think about. And so I ended up building a giant BSP tree based on all of the input. We call them brushes. That was what Quake called them. I don't know why, but they're these um chunks of 3D geometry that either that represented the solid or not solid or whatever, um, were constructed from polygons because they were some kind of shape. So you take all of those polygons and you put them into a BSP tree. You take all the polygons from all the brushes and you put them into a BSP tree. And one of the things the BSP tree does is you can view every leaf of the BSP tree as a convex solid. Or if it's on the boundary, it extends out to infinity. But in the in the basic case, it just turns out like that's because you're continually slicing by planes, every single one has to be convex. And that meant that every uh convex thing that wasn't inside a wall was a cell in my portal cell model. So I could just, do that. And if you built a room just as a simple stretch cube, it would work out that way and you would just get a single cell. But if you put like a pillar and a whatever, it wouldn't. It would be more complicated. But that was correct. Like, yes, like if you had a bunch of pillars in your room, you would have lots of portals cutting across. Like that's just how that system had to work. Um, which was not very efficient and was fine for the software render, but when later that same engine got used for a 3D graphics accelerator, GPU. Only when it was hardware only, it was no longer a very good engine for that because it paid all this overhead of slicing things up into these portals that it didn't really need. Anyway, so um uh we can talk a little about constructive solid geometry if you're interested.
I learned about it during my university, so I have a fair idea what is it. But maybe you should
Our audience doesn't. Yeah.
yeah,
So
exactly.
all right, so let me tell you what Quake did. Okay, so all right, so constructed solid geometry, the basic concept idea is you take two objects, like you have a cube and a cylinder, and you stick the cylinder through the cube, and you say, take the union of them. Well, that's just the cylinder and the cube. But in modern graphics, we would just draw the cylinder and the cube and be done with it. But the CSG process actually finds the boundaries between those things and creates a single continuous volume without any overlap. Um, the the more exciting one is that you subtract the cylinder from the cube, and now you have a hole through the cube that's cylinder shaped. Um, and so there are a couple operations you can do. You can do union, subtraction, intersection. So what Quake did is it started with an empty world. Like we need a word for this. So I'm going to call it air.
Okay.
Like that, it's void, it's
Void, yeah.
space, it's open, but I'm going to call it air. Just bear with me. I'm going to call it air, and all will become clear eventually. So in the Quake model, you start with air and you put down solid brushes. So you have shapes, so you can build walls, and you build walls around the room, and the walls are solid. So there's a face facing into the room, and there's a face sticking out facing away from the room. And then you can put some pillars in, and then maybe you want to subtract, maybe you want to put a hole through a cube. So Quake, I've never used Quake, but this is my understanding. Quake had a subtract operation. And so you would take a cube and you would stick a cylinder through it and you would say subtract, and it would output effectively some new brushes that were the cube with the hole in it. And you wouldn't have the cylinder and the original cube anymore. It was a destructive operation in terms of editing. Now, maybe it wasn't actually destructive. Maybe it kept all that and did all that at the end. Like, I think it might have done something like places all the solid objects, then subtracts all the subtractive objects rather than it being an operation so that the designers could have a little bit more state. Um, and then there were water brushes because you can have liquids, you can have lava and water in Quake. So those, gosh, I don't even know what the operation is. It's right. So it's a little more subtle because now you end up with a space that is liquid, that is water or whatever. So the model is that basically you take the space where all the liquid is and you subtract all the solids out of it. I don't know. It's something. There's some model there with Quake, and I've forgotten it. It's been too long. The model that we had was totally different. In our model, everything starts solid. I believe this was actually what Unreal did too, but I'm not 100% sure. I don't even know if it was CSG, but I think it was. Um, we start solid, and then you put down an airbrush, and that creates a room, right? Because instead of the room being made of four walls and a ceiling and a floor, which also have these other polygons sticking out, you just place a single box in the thing, and that gives you a room inside a dungeon, effectively, right? It's like still thinking of it from the dungeon perspective, whereas Quake is thinking of from like, how do you really make this? The thing in Quake is that a lot of the times you were making these spaces where you only ever saw the inside of the room. You never saw the outside of the room. Like you'd have corridors or whatever. And so Quake actually had a whole separate step where they would flood fill from the outside and find all the polygons that you would never see and delete them from the level.
Okay.
That's like as part of
Yeah,
the
yeah,
compilation
yeah.
phase at the end. And so we didn't need that because we never built those unneeded things. But our model was just totally different because what our model was that you remember in that CSG in the BSP tree, we've ended up dividing every single the entire space. So the quick thing didn't do any BSP stuff at that stage of the CSG. They just intersected all the brushes, figured out all the polygons that they needed, and then they went to a BSP tree. We started with the BSP tree, found all these final leaf areas, and then for each area, um, gosh. Okay, imagine Photoshop. You have Photoshop layers, right? But instead of thinking of Photoshop layers as being stacked in space, like vertically, think of Photoshop layers as being through time with Painter's algorithm. Like
Yeah.
first you put down the first layer, now you apply this layer, now you apply this layer. In Thief, we had all these brushes through time, and you would apply each brush in order. So first you would dig out a hole with a brush. Then you could put in a water brush. And the water brush could be really big, and that would turn the entire thing into water, and that's not what you wanted because you were just trying to flood that room. So in addition to a water brush, we had a flood brush. And the flood brush says if the leaf that or like we just apply this to all the leaves in order through the timeline. The flood brush says if the space is currently air, turn it to water. Otherwise, do nothing. So it doesn't affect a solid brush. It doesn't affect a lava brush, but it does affect an airbrush and turns an airbrush to water. Um, so you had this whole sequence of operations you could do, and that let you like flood and effectively flood an area. You could build out the area, and then you could put the water in and just have a big thing of water, and the thing would figure out exactly where all the water goes correctly. Um, and you could do arbitrary subtract. You couldn't do like the whole thing is with real CSG, you can build kind of arbitrary trees. You can say, okay, take that cube, cut the hole in it and have a cylindrical hole in it. Now take that whole shape and subtract that from something else.
Yeah.
Like that's the kind of thing real CSG could do. You couldn't express that with our system. However, we had four kinds of, we had air, solid, let's call it earth. We had air, earth, lava, we could call it fire, and water. So we had, the four
Four
classical
elements.
elements.
Yeah.
By coincidence. Like it's just actually what like Ultima Underworld had walls, open space, water, and lava. So it wasn't like this was a novel invention, but we were suddenly treating all four as the exact same thing. And that was what was new. And that was why that was kind of funny. But anyway,
Okay.
so that
Okay.
was why I set up the air thing.
And this was
But
this is like a level editor where you're sequencing what you want to
yes,
do, and this
but you can't tell what the sequence is. There was no way to, I mean, you could step through the brushes in order, but visually it was just this crazy stacking of 3D
Okay.
brushes. I'll rewind and talk about that a little bit in a second. But so one thing is that I basically implemented all of the turn this type into that type as a brush type. So you could turn lava to water, or you could turn solid to water, or you could turn, whatever. And the designers eventually figured out. So the thing is that we mostly only gave them stretched cube brushes. We didn't let them make weird arbitrary shapes. So the only way they could make arbitrary shapes, like a hexagonal tunnel or something like that, is if they could figure out how to intersect things together and make it work. And so one of the tricks they came up with was like, okay, they're not using any lava anywhere in this thing. So they would like put in a brush that would turn air to lava, and then later put in a different brush that would turn lava back to air. But like by doing that in the right combinations, they could produce tricks and get like seamless edges where, so it's
Yeah.
one of those classic things where designers come up with something clever that you never thought of. And it helped that they were MIT graduates that were coming up with that. Um, so yeah, so what happened was I had done that original graphics research and had the 3D joust thing. And then we had the CSG and we were like, okay, I think I can make the CSG thing work. And Doug Church and I went and made a first draft editor for the brushes that let you position them in 3D and then run the CSG thing and test that we could build a level. Like, is this a system that we could use that would actually make a level that we feel like is usable? So Doug and I just did that all by ourselves and got it and was like, oh yeah, that's good enough. And that editor that we did, I'm pretty sure continued to expand and turned into the actual editor that the game used. I don't think it was a prototype editor. I think it was turned into the real editor. Dromed is the people who follow the Thief community will know. So, right,
Okay.
because the game started life as Dark Camelot. So
Yeah.
there's a camel pun of dromedary. It's like a dromedary is the category of animal that a camel is. So
Okay.
one of the people said, so it's Dromed, and because it's Dark Camelot. And
Okay.
so that's how we ended up with Dromedary. Um and yeah, Dromed. So yeah, so Doug and I did that, got the CSG approved out. However, I do want to mention the CSG system was terrible because we used the BSP tree to do the whole thing. And one of the things that happens with the BSP tree is that the first planes that you put into the BSP tree cut across the entire space. Eventually, as you keep putting in BSP planes, you're subdividing the space. The first plane of a BSP tree splits into two half spaces, and then the next plane splits that into whatever. And eventually, you put in enough that it now becomes a convex finite space. But what would happen is the first brush in the timeline order would be put in and it would be at a weird angle. And so it would just put in a plane cutting through the whole level. And that's okay. It works. But it does mean that, like, oh, then like every single space, every room that happens to intersect that is going to get some extra polygons because it got split by that. And we had no way to undo that. Um, and uh I learned later, like looking at the Quake source code or something, that like a simple trick you can do is you can just put extra planes in out of order just to split up space. Like there's no harm to adding extra planes early on in the
Mm.
process. It doesn't
Okay.
hurt anything. And so you could just put some axis aligned planes in, like go through all of your brushes and say, what are some axis aligned planes that are on big brushes? Okay, put all those in first. Then later, when we come back to them, we'll add them and try to add the plane again, and it's already split, and it doesn't, matter. But that way, we don't have weird angled brushes intersecting, because what actually happened is that once the levels got big, they would run the CSG processor, and it would say epsilon error and fail. Because guess what? Graphics, 3D geometry is really hard. And I, I had, done an epsilon for plane closeness testing and done all that stuff. And my CFG was not very robust. And it turned out that that did bite us towards the end. I took the CSG engine and I put a type def at the beginning that changed from float to double, and that fixed it 99% of the time. And I said, that's good enough, ship it. But if you, again, in the fan community,
Mm.
they were, still using Dramid, and they would still hit those CSG errors and hate life.
Okay.
So as they were making fan missions. So yeah, I'm not perfect. I absolutely, bit off a little more than I could chew. Didn't fully understand how hard CSG is, and how hard that kind of uh, geometric math is, and totally screwed it up.
What about lighting?
Yeah. So we had already copied this idea of CSG from Quake, and then because of that mailing list, I might have had some foreknowledge of how Quake did its light maps.
Might have.
Right. But one thing that definitely happened was Q-Test came out. So Q-Test was a technical preview of Quake. I haven't actually opened up my notes that I made. Here's my notes. Okay. Um, Q-Test came out in 1996, February 1996, and we didn't ship Thief until 1998. So this is long before Thief came out. But Q-Test came out, and so Quake had these light maps that let them have really nice shadows on the walls. And I think what happened was we saw that and went, gosh, we've got to do that. I don't think we even knew we were Thief at that point. We already knew, like, that's just too good. We've just got to do it. And then once the game became Thief, obviously it would never have worked without the shadows. So, so the idea of light maps is that you take your texture space and you've got, textures. Your texture is at some detail level, some level pixels, and every 16 pixels or something, you put a light sample and you interpolate the light samples over the entire surface of that texture. And so the texture is not unique. The texture is shared and reused across all of the other surfaces that have it. But for every wall, every floor, every ceiling gets a unique light map that says what the lighting is on that surface. And in hardware, this is very easy to do. It was actually applied very early. 3DFX supported multi-texture very early. So you just take two textures. You put one texture that's your actual texture, and then you take your light map texture at a scaled up and multiply them together, and that gives you the lighting. But we couldn't do that in software. So I think we just did. We either knew what Quake was doing, or it was just the obvious thing to do. You can't afford to do that lighting in runtime. So the whole thing is, up till then, we were doing vertex lighting. So you have a lighting at your vertexes and you interpolate it. And when you have
Yeah.
a big wall, it doesn't look very good. But it's what you can do. It's what System Shock did. And um yeah, let's not go there. Uh and so um the the way you do it in software is what Quake calls a surface cache, which is that you build that unique texture with lighting baked into it for every surface. You just build it and then render that, but you only build the ones that you can currently see. And so you have a cache of all the surfaces you can currently see that have the lighting baked into them. And so the texture repetition is no longer repeated because the lighting doesn't repeat. So you repeat the texture as many times as is needed. Your surface cache textures probably are only like 256 wide at most. So if your textures were 64 by 64, they get at most more repeats. If you built a big wall, you have to split that wall into small enough polygons that each one fits in the surface cache. Um, and then and so now you just need to get lighting values at each of those grid things, and that's just a pre-computation where you raycast from each point to all the lights and see which ones can see it and compute what the lighting response should be.
And on the character, you do it
So
because in Thief, like the core feature in terms of gameplay is that you're a thief and you know how much light is there on you and how visible you are.
yeah, so two things I should establish. One is that I only did the terrain
Okay.
rendering engine, but I do know all this, and I did touch some of the other stuff. But Looking Glass had a robust tech team who did tech libraries that were shared across all the projects. So like in Terra Nova, I said that we had this crazy strip region, but in the foreground we had regular polygons. And those polygons just were done by the tech library. Like we just had reusable library. But like I said, they weren't subpixel correct and weren't subtextual correct. So for Thief, I didn't use those for the terrain. I wrote my own things. We can talk about the perspective mapper, actually. We should. That's a big deal.
Okay.
Um, and um, so, but the object rendering still used the existing object rendering path. Um, like for example, using the BSP planes for sorting. Couldn't do that for characters, like with character animation. I don't remember how they got sorted. Um, but I did write the code to take every object and every frame, take every object and raycast all the nearest light sources and see whether they were in shadow or not. And then it would apply a single brightness, a single decision for each light source, whether it was close enough. It would still compute per vertex lighting for that light source, but just the decision of whether a light source was. So the entire object would go into shadow all at once, basically, when it went
Okay.
behind something. But I don't know if we shipped that. I wrote it, but I don't know if we shipped it. I
Okay.
do know that on the player, we had that, but we didn't use it. We instead used the lighting value on the floor under the player, the nearest light map, because we wanted you to be able to look across the room and say, oh, that spot's in shadow. And the only way you would do that is by looking at the floor. And if you went
Um,
over there and you stood on that spot and the floor was in shadow, but you're up higher and the shadow is sloping through space, and now you're not in shadow, we had a light gem. So you would be able to know it, but it just wouldn't feel
yeah.
like it wouldn't feel right. So I'm pretty sure the shipping game just uses the lighting on the floor under the player.
Okay.
Uh, and it might not have used the light map. Maybe it did the same shadow probe thing, but it probably used the light map.
Okay. That explains my confusion from the childhood playthroughs. But I played the later Thief, not the very first one.
Right.
So I'm not sure how that changed.
What, you played Thief 2 or one of the even later?
I started with the 3, the
Yeah, I
Deathly
mean that wasn't
Shadows, and then went back.
that wasn't Looking Glass, yeah. So
Yeah.
um Thief 2 still used the same tech, it just was hardware accelerated only. Um which
Okay.
was, like I said, was a performance problem.
Okay.
Um and there's still more to talk about actually with portals themselves.
Okay. Let's do that. Let's do it like this. First, I think we should do a little bit of break. If you want to wrap all your work and step back, what would be the mindset shift that you need to have for the software renderer compared to the hardware renderer?
I'm going to answer a totally different question because I think the analogy will be insightful.
Okay.
So I posted on my Twitter or Blue Sky, I posted a screenshot, or actually a little animation, a little video of a game I was working on in the 2000s with that was graphics. Sorry, it was a hovercraft combat game. So and the clip, I dug up the old XE and ran it and it worked. So the clip is just, you're hovering over a terrain, and it's kind of inspired by X-Wing TIE fighters. So you're shooting at these enemies that are also driving around. And if the graphics are terrible programmer art, but they're like real textures, and like they're trying to be polished, but so they're not programmer art exactly, but they're not great aesthetically because I'm not a great aesthetician. Anyway, but the point is, like, when I posted it, I was like, this is really weird that it's a prototype for a game. Why did I put so much energy into like doing this sort of polished graphic? Because like the texture on the ground doesn't repeat. It's like, it's switching back and forth between two textures in an irregular non-repeating way that looks really good. I mean, it doesn't look good aesthetically, but like technologically good. And the things have shiny highlights on them and stuff. And I posted, like, it's a little weird that I put so much work into the graphics. And then later I went and I found the source code for it. And uh, uh what happened is that that engine was written using something called register combiners, which I'll explain in a second. Um, and the whole reason why I went to so much work, it was because it was unclear what you could do with register combiners. So I had to actually implement all this stuff to even find out what was possible. Whereas all the things I just described, you could just trivially do on a modern GPU. And so register combiners really quickly are just, before they had programmable shaders, they had these almost programmable things where the idea was you could have multiple texture samples. They had multi-texture, but then it's like, well, you can multiply them, but that's kind of boring. Like, could you do something else with them? And so register combiners were like just almost ready to be shaders. They were like, I think the version that I was using, they had 3 stages, and in each stage you could choose which of textures to add or composite or multiply together, and she could program a little bit of cleverness. And so
Okay.
you could like, so like, the math for hacky specular is that you take some vector dot product and you raise it to the 10th power or some power to get a tight spectral height. And so the whole thing in this was like, well, you could multiply a thing by itself and then maybe multiply that by itself and get to the 4th power in the register
Okay.
combiners. So I was like testing, oh, can you get a spectral height? So the point of this analogy is that, like, we just take for granted all of this stuff that it can trivially do on a modern GPU because they're programmable shaders. And so even just going back to 2005 or whatever, when the shaders weren't programmable, but we saw graphics hardware, you had to go through all of these craziness to just get this basic effect of like a specular highlight or, you know, uh, some, I don't even know what, like fog or something. So, the point being that software rendering was just like so vastly different in comparison to, like, register combiners is like a nightmare to do compared to shaders, and yet it's just very close. The hardware is not that far removed. Software rendering is just so far removed that, like, to say what the mindset or the it is very difficult. It's a lot easier for me to, like, talk about piecemeal, "Oh, here's one of the things we had to do, and here's one of the things we had to do." Trying to, like, kinda capture a big picture view of it, I don't even know how.
Okay.
So
Okay.
I don't so I had a non-answer to your question, so it
Good enough.
interposed a different thing.
It's a good enough.
Um,
It gives me
so
picture.
for example, like I was saying, like, um, ideally want to spend 90% of our time rendering the frame. And most of that time was spent looking up textures because the math needed to compute what the correct texture coordinate was and then reach out into memory and fetch the texture, and that memory, isn't necessarily cached or whatever. That took a lot of time. And so just doing that, like, was a huge optimization task of just, can you get that down to 4 cycles or whatever, you know? Um, just that. And then you actually still cared about your outer loop and your and then you had all the other big picture stuff like thinking about lighting. Are you interpolating vertex lighting, which we did for objects. Objects were all interpolated vertex lighting. Um, how do you do lighting in a software renderer? Like, you've got a lighting value and you've got a texture value. Now what? You can't multiply them because, first of all, the texture is actually a paletted texture. It's like one of 256 colors. And so it's a lookup into a color table that you set for a whole screen. Like, the way the frame buffer in that era worked is you said for the screen, it's an 8-bit frame buffer, and here's the 256 color palette for it. And you provide a 8-bit value for every pixel, and the hardware, while it's generating the display, does the lookup in the palette. So in the inner loop of your texture mapper, you have a texel value and you've Gaussian and computed a lighting value. Well, now you have another table. It's a lighting lookup table, and you put the pixel and the lighting value together and look that up in a 2D array. And that gives you another paletted value, which you don't have enough colors to do it very accurately. So the lighting don't look very good, but it's better than nothing. And that's how you end up with a lighting value. And so just doing that, well, how do you interpolate those texture coordinates and how do you interpolate the curve shading? That's expensive. That takes a whole bunch of cycles. The crazy stuff for that. Um, so you have all of these different aspects to worry about. You have to optimize the inner loop, you have to optimize the outer loop, because that we talked about that with Terra Nova, that the accounting the edges actually matters once you're drawing a lot of polygons. Um, an example of that, because all I can do is give you examples. I think so. What we did in this particular era was we targeted the Pentium, because the Pentium had a very specific way of doing uh, more than one instruction per cycle, whatever you call that. Uh, there's a word for more than one instruction per cycle, but I can't think what it is.
Yeah, but
Um,
you mean that the one starts and you have another one like this, and they
that's pipelining,
okay.
which is one instruction per cycle, but they overlap. Uh, Dual issue or whatever was on the Pentium is you actually can execute two instructions simultaneously if they don't need the results from each other. So
Okay.
you could like add to one register and add to another register at the same time.
Okay.
Um,
Like
so
parallelism.
yeah, instruction level parallelism.
Yeah.
I can't think what it's called, but so the later processors like the Pentium Pro or the Pentium 6 or whatever started introducing out of order execution and things like that, where you could get deeper into, like, you could be like, well, the first instruction and the third instruction can proceed at the same time, but the second instruction depends on the first instruction, so it can't run yet, and could start doing that stuff. Payam was very simple. It could execute two instructions at the same time if they didn't interfere with each other and they obeyed certain rules. The 486 was the first Intel processor to have two things. It had a floating point unit, and so all 486s had floating point units because it was an add-on. For the 386, it was an add-on you could buy, and you couldn't, as a game developer, you couldn't expect your audience to have it. The 486, you always had it, except then, of course, later they released a version of the 486 that didn't have a thing. I had a floating point unit, and it had what we called a risk core, which was there are a whole bunch of instructions that guaranteed to execute in one cycle because of pipelining. And therefore, if you only use those instructions in your tight loop, you could be very precise about how fast that loop would run. But ignoring memory latency, like, yeah, and anytime you load from memory, of course, it was unpredictable due to the cache. So the Pentium had this risk core, a whole bunch of instructions that you could guarantee would only take one cycle, and you could issue two of them at the same time if they didn't share work. Um, that I think the only meaningful restriction there was that if you wanted to use it, want to fetch from a memory address using a register pointing to the memory address, that register couldn't be computed in the previous cycle. It had to be two cycles earlier. Like, so just some weird constraint that you have to do. And so you would sit there and you would optimize out your assembly and you'd go, okay, I can do this texture mapping loop with grow shading or whatever it was in 4 cycles. And, including the loop branch back to the top or whatever, or 5 cycles or whatever the number was. Let's say it was 4 cycles. And you'd be like, okay, that's great. That's going to like increase the number of pixels we can push in a frame, or more importantly, we can increase our frame rate, because our goal was actually always to either run at a higher res or to get more frames per second, because we weren't running at 30 frames per second most of the time in these games. It was hard to get. Wait, because we were pushing, it's what we were talking about. We were pushing the boundary, and you would push the boundary by letting your frame rate suck. And even Doom was doing that. Like, Doom's frame rate wasn't great. Like, it had a cap of 35, I think. Because it was released in the 486 era, and so it wasn't until you had like a Pentium 90 that it would just max out the frame rate all the time. none of this means anything, but 486s were clocked typically at 33 megahertz or 50 megahertz. And so then the Pentium 90 was a 90 megahertz Pentium. So it was both Pentium with a parallel instruction issue, and it was 90 megahertz. So anyway, so the point is that, so the example I was trying to get to with all this is that, like, you'd be like, okay, great, I got the inner loop down to 4 cycles. So I wrote, I mentioned Flight Unlimited. There was a Flight Unlimited sequel, Flight Unlimited 2. And um, the way most of the Looking Glass games rendered is that they had, we had a perspective mapper. The tech group had a perspective texture mapper, and we would use the perspective texture mapper for the nearest polygons, the biggest polygons. But when you got further away, we would switch to a non perspective correct texture mapper, an affine or linear texture mapper. And that was just for efficiency, because they rendered faster and you needed to draw a whole bunch of them, but also they're small and the distortion was less obvious. So we could get away with it most of the time. It wasn't offensive. So anyway, I think this is when I was not employed at Looking Glass. Uh, I sat down and I said, one of the problems we have is we're drawing all these smaller triangles in something like Light Unlimited. And that, as your triangles get smaller, your outer loops, your edge processing, your triangle processing becomes more important, because you're only pushing a few pixels for each triangle. So getting the optimized inner loop of pushing out a textured pixel as fast as possible, if that's making your setup expensive, maybe isn't the right trade-off. So let me see if I can write a triangle mapper that is affine only, but let me figure out how to optimize the triangle setup and the edge setup and see what happens with that. And I ended up with an inner loop that was 1 cycle slower per pixel. So it spent, every pixel it drew was 1 cycle slower than my normal one. But the setup was much faster, and it was actually faster. I actually have it running in DOSBox, but it doesn't matter. Like, it's not significant in any way. But anyway, so I brought that in and showed it to him. It's like, look, this is way faster I mean, I wasn't comparing it against our tech libs. I was comparing it against my stuff, uh, but I was pretty confident that it was going to be faster, because it was like really smart about how it did its setup. And I'll come back to it later after we talk about something else. But the problem was, you remember we talked about being sub-pixel correct and sub-texel correct, or whatever. So one of the things about that is what's called a fill rule. What you want to do is, when you draw 2 triangles that are adjacent, like they share an edge, you want to draw every pixel exactly once. Like, along that boundary, you don't want to draw some of those pixels twice. So you want a fill rule, a fill convention that guarantees that one of those triangles draws every pixel, but no pixels drawn by 2 of them. And so the problem was that the triangle mapper I had written was 100% assembly, Pentium optimized, down to the wire, and it had a different fill convention than the existing Looking Glass texture. So we couldn't just drop it in and have it work. It needed to be rewritten to, like, match those rules, and I didn't want to do the work. I'm not even sure it was possible, because of how the perspective mapper worked. So it was like, we didn't end up shipping it, but I had done the work, and it was a true fact. And so this was what I was getting at. The whole point of this example is like, the right trade-off seems to be, oh, let's make sure we can load every texel as fast as possible, get those texels loading as fast as possible. Oh, no, it turns out once you're drawing more triangles, the outer loops matter too, and you no longer want to have that inner loop be as fast as possible. It's like, oh my God, there's so much craziness. It's just insane.
Yeah. And on the level of platform, you said that you were targeting Pentium.
Mhm.
But how does this work? Like, how often the news?
Yeah, I think I know where you're going. So let me just explain. Basically, we would have a min-spec machine.
Yeah.
And maybe the min-spec machine was even a 486, not a Pentium. But basically, the idea is, you'd say, okay, we're going to target this Pentium. I mean, the thing was, the Pentium was just so good to target. Like, it was a sweet spot that we could really nail it. And so the whole thing was that, like, if you target the Pentium, any later processor would just be faster anyway. It's a faster processor it's getting more instructions and it has a higher clock speed. You won't be optimized for it, but it'll run the game faster than it runs on the Pentium. And so you're just like, that's good enough. We target the Pentium. It runs good on the Pentium. If you go down to the min spec machine, you get 10 frames a second. Sorry, we're not going to also optimize for that. We'll optimize for a good experience on the Pentium, and you'll get a great experience on anything else. It wouldn't be the optimal experience on the other things. We could optimize for all of those things, but no, we just didn't. We pick one and
Okay.
optimize for that.
Okay. But then, were there situations where, like, Pentium, for example, there was new algorithm in the CPU or a new mechanic that was introduced, for example, the out of order execution, but it messes up what you were using for the previous architecture? You know, like,
So we actually, so it would get worse, or so it just wouldn't be optimal.
like, it would get better for the most cases, but the cases that, like, abused certain or used to the, used some certain mechanic functionality, it would get worse. Was this
There was one big one. Do we want to get technical? We can get technical and I can explain it because it is a funny one.
Let's do it.
Okay. The big thing in texture mapping is that you have a UV or ST coordinate. You have a coordinate in the texture somewhere. And so it's a grid of texels. And the way you do a 2D array, it's a 2D array. And the way you do 2D array lookups when you have to explicitly do the math yourself is you multiply Y by the width and you add X. Y times the width plus X. But remember, multiplies are not fast. You can't actually do the multiply. So there was some trick, and I don't remember what it was, that we did for the surface cache things in Thief, and that the way normal looking gas mappers worked, because they could just handle any arbitrary width. I think maybe they only handle powers of 2. So one of the ways you do it is you use a shift instead of a multiply. If the X and Y axes are powers of 2, instead of Y times width, it can be Y shift left the log 2 of the width. So I think that was one way people did it, but it meant you had to spend some time. You had to take your Y value, you had to shift it, you had to mask the X and or it with the Y. It was a couple instructions. It's not super efficient. It was, whatever. There was some crazy trick that was used in Quake, or that we used, or that 3D Realms used for Duke. I don't remember. There was some crazy trick that allowed you to have an arbitrary width and somehow carry. So, basically the idea is, yes, we'll talk about this. Okay. The basic thing that you have to do is you have to interpolate the U and V across a scan line, a span of the triangle or polygon. And that it's just a linear interpolation, but you want to do it step by step. And you don't want to use multiplies, so you don't use a lerp function. So what you do is you compute a delta that you have to step by each time. So you add that delta to the U, and you add that delta to the U, and you add that delta to the U. And it has to include a fractional precision so that you can step smoothly across a variable amount. So you might be stepping by more than one U pixel at a time, but you're also stepping by a fraction. So you're stepping by, 3.7 every time in the U value, or whatever it is. And so you have to somehow represent that. If you use fixed point, because you can't use floating point. So you use fixed point. You can either so one way is that you store a fixed point value and you add some other fixed point value every pixel. And then somewhere in there is the integer component, and you shift the integer down and extract it. And then you have to shift the other one for the V and merge them. It's a bunch of instructions. You'd prefer not to do it. So there was some trick that I don't remember what it was, that maybe you've created a table. So what would happen is, if it was 3.7, integer value would step by 3 or 4 every time. If you only looked at you had to compute the full thing, but if you only looked at the integer, it would step by 3 or 4. So there might have been a thing where it was you stored a 2-entry table that had 3 and 4 in it, and somehow were able to, you would only add the fractions and keep the integer separate, and then use the carry, the when you added the fractions, there would be a carry generated if it overflowed, and you could use the carry somehow to index into the thing. I don't remember what it was. Anyway, there was some trick for that. But what I did, which I think was unique, I'm sure somebody else did it. There's a whole thing that we haven't even touched on, which is that I'm constantly reinventing something somebody else already came up with without knowing it. So like, anyway, we probably skipped over some examples of it already, but so the 486 and the Pentium were 32-bit machines, which means the registers were all 32 bits, and you could work on bytes, or you could work on, from memory, you could access 32 bits, or you could 16 or 8. But the 486 and Pentium came from the 8386, which came from the 8286, which came from the 8086. And the 8086 was a 16-bit processor. So the registers in the 8086 were AX, BX, CX, DX, SI, DI, some other bits. But each of AX, BX, CX, and DX, because it was a 16-bit processor and it was coming from the 8-bit era, they were like, you know what? We're going to let you can either use AX, or you can use the low byte of AX as one register and the high byte of AX as a separate register. So you could have two 8-bit registers, or you could have a 16-bit register. And, that gave you more registers to work with if you had 8-bit dice. And that was all preserved all the way up to the 486 and the Pentium and the Pentium Pro. You had EAX, which was the 32-bit value, AX, which was the 16-bit value, and then the 8-bit values. And a lot of those, like when we went to 64-bit, they were very clear. When you load EAX, the 32-bit value, the 64-bit value gets zeroed at the top. But because of that historical use, if you loaded AL, it didn't zero out
Oh,
AH and EAX. It just changed the bottom byte.
yeah.
And the x86 has an add with carry instruction. So there's a carry flag. So if you add two numbers and it generates a carry off the top, it gets saved in the carry flag. And then you can add something else and add with carry. So it lets you make big adds. You could make a 120-bit add by propagating the carries all the way up. So the way some of my texture mappers work is you would add the fractional bits of the U together, the U and the U step, and that would generate a carry from the fraction into the integer. And then you would add carry to AL, which was the U. Then you would add the V fraction in the V fraction step and add carry into AH. And so your texture was 256 by 256. Like, you didn't have any choice. You could actually mask it to be smaller, but it would always be like the stride was always 256. The next row of texels was always 256 after the previous row, even if it was shorter than that. But that actually was a really optimal loop, like, because you didn't have to do any shifting and inserting. It just magically happened from AL and AH. You did have to do it as an add and an add carry, but you didn't have to do any shifting and assembling. They just ended up in the right registers. And then you remember I said that, like, one way to do the lighting is that you have a lighting value, and you have a 1 byte color value, pixel value, and you look that up in a 2D table that's the lighting by the other thing. So if you wanted, you could have an inner loop where you wanted to compute a lighting value as well, and you would do that by you loaded once you finally got your Q and V, you in AL and AH or some other register probably, you could then fetch from EAX to access the texture and bring that into BL, the low byte of the B register, but you already in B8 had computed the lighting value, and so now you can load from EBX and get the final lit pixel. Okay, so this did not ship. This example did not ship, but that thing I just described is how the some of the texture mappers I wrote works. I don't know if any of them shipped, because once we put in the light mapping, it all changed. But I was working on a research one that was totally crazy, that was Pentium optimized. And what it was I wanted to be able to do a big outdoor terrain of some sort. And so what I did was I made it tile mapped. And so tile mapping is when you store a grid of tile indexes and then use the tile index to look up a tile. Maybe the tile is 8 by 8 or something like that. So I made a texture mapper where you take the U and V values and look those up in a tile map. And then you take some of the fractional bits of U and V and look in that tile to get the final actual pixel color. Um, and that let you make a big tile mapped thing. Like I said, I have a demo of this running if you want to see it. But and then I wanted to do lighting. I wanted it to be able to compute semi-dynamic lighting. So the idea is you'd store a lighting value at every vertex. But I wanted to do colored lighting. And I think I had it cheated. I think I couldn't, there was no way to store and make the lookup work. So I think what I ended up doing is storing for every tile, it would store the lighting at the corners, but it would store a color for all of it and then a brightness level for the four corners for every tile. And it actually stored them separately for each tile, even though it was shared redundantly with the things, because you couldn't afford to access these other things. So what it did is it stored those four values packed together into a single byte that was a paletted representation of the four things. It was an approximation to, so it's like if it's supposed to be 3, 3, 2, and 1, maybe it's 3, 3, 2, and 2 because there were only 256 allowed possible combinations of the thing. So it was like an approximate lighting edge. And then it stored baked, uh, interpolated lookups of those for each spot within the tile. So there was a table that was basically just a texture that was, okay, how do you interpolate this paletized lighting value correctly? Anyway, the upshot of this is that in this inner loop, I think it was 18 instructions long, so 9 Pentium cycles, something like that, which was like, the idea was like this was forward looking. But anyway, it used that EAX, the low byte, high byte trick like 5 times because of all these different tables it was looking up. So the Pentium Pro came out, and not the Pentium Pro, the Pentium 6 came out. And so the Pentium 6 was out of order execution. And one of the ways all these out of order execution machines work is they have more registers under the hood and they rename like you ask for EBX, but it actually assigns you register 37
Oh,
and like, I don't know if you know any of this or whatever, but so, and computes that value into register 37. And the P6 may not have worked exactly like this, but the point is though that like, because you're being out of order and you want to get things going, if something happens to use the same register, but it's overwriting it, so it doesn't care what the old value was, you want it to be able to run. So you just assign it a new register. Um, so as a result, when they were designing the P6, they were like, well, it's valid code to write into the low byte and then read the whole thing, but it's not a common thing. Like compilers don't generate that. So we're
exactly.
not going to optimize that path. What that path, one of the designers called it a last jaw, one of the Intel designers. Like, if you happen to be doing that thing in an inner loop, it will be slower than the Pentium, even though it's a faster clock rate and a higher thing. And I was doing 5 or 6
Hmm.
of them in this inner loop of this thing that wasn't shipping code, it was research code. But it was still like, I was like, oh, look at this crazy thing. I mean, it doesn't look crazy now. It's like, oh, colored lighting on a big texture. Like, it's not at all interesting. But at the time, it was like incredible. I was, oh, I've got this great thing. And then we got a P6 in and I tried running it on the P6. And I was like, oh, it's slower.
Yeah, yeah,
I had no idea why at first. Like, so
yeah.
yes, that was a possibility, but for the most part, Intel was pretty good about not doing that, and I don't think anything that we shipped ever had that problem.
Okay, okay.
But
It,
it's definitely a thing that could happen. So yeah,
it
that's why I told you the whole Shaggy Dog story about a thing that never shipped.
it must have taken you a long time to figure this one out, probably.
Yeah, I'm not sure I had any way of finding out why it was slow because it's
Yeah,
just slow. And then
exactly.
like you profile you could, even if you had like the hardware profile or whatever, like eventually they started having that thing where you can get the counts of events or whatever, and maybe there would be an event for this and you would potentially be able to discover it. But at the time, I don't think there was anything like that. So yeah, I don't think I had any way of finding out until at some point someone said somewhere on a mailing list or something, somebody said, "Oh, if you do this, it's slow." And I was like, "Oh, well, that explains that."
The secret mailing list.
I might also just have been able to guess because, like, what else was I doing in that code that was weird?
Yeah. Um,
Um,
any other stuff on Thief graphics?
oh, well, what was the list that we had before we went on break? It was perspective mapping, and there was something else.
And you said that there's one thing to add on Portal and Cells, but you didn't specify what.
Oh
So
dear, I have no
I'm
idea what it
I'm
was now.
counting on your memory now.
Oh, I do know.
So let's do it.
So, okay, let's do the portal cells first. So one of the things, so the way Quake worked, is that they read the same research, and he did a thing that was called the pre-computed visibility set. I don't even remember the exact PVS, pre-computed visibility set. Yeah. So he just said for every cell in the entire map, build a list of all the other cells that are visible from it. And it's a conservative choice because depends, like if a cell is big, long room with windows, then and you could stand anywhere in that room, then you can see a lot of stuff out of it. So it's not perfect, but they had the experience that if you went to one corner of the level and looked that way, they had a system for uh occluding stuff, but it still was trying to draw all of the triangles. Um, they had a they used a back to front, sorry, we were back to front. They used a front to back running. So sure, really quick. They it was a famous technique at the time that almost no one ever did, but everyone talked about that you could do, which is that you could render front to back and then clip when you would have a polygon and you would need to draw a line, you would see, oh, there's already something drawn in front of it, so I don't need to draw that part of it. And so you could skip doing the texture lookups for that and, clip it down to only the part that was visible, and that would save you some processing. And the problem is if they drew a whole level, they would quickly fill everything, but they wouldn't know that they didn't need to draw the further away stuff. So they added the PVS so that they would know, I just don't even need to try to draw this. You could try to figure out, oh, I filled all the spans, so I don't need to draw anything anymore. But it's like, well, I filled some of them, but not all of them. Like, so just that was easier for them. So we didn't have anything like that. We traversed the portals at runtime to figure out what was visible. So we got a tighter bound because if you were in a room and you were close to one window, you would see what's through that window, but you wouldn't see what's through the other window. And uh, the way we did that was with what I called octagonal bounding boxes, because the portal shape would be some arbitrary polygon in perspective, so it could look like that. And trying to track through the intersections, because you would see through a portal through a portal through a portal, so you need the intersections. And trying to do those intersections didn't seem very efficient. So you could make a bounding box of each one and track the bounding boxes intersections, but that would overestimate by a lot because they were bounding boxes. So we took bounding boxes and then added 45-degree angled bounding box. So it's like you have one bounding box and then one 45-degree rotated bounding box, or effectively an deformed octagon or whatever, like something with 8 sides and they're all 45-degree angles, and did the intersection calculations on that. And that was a lot tighter. And uh, when you drew a cell that, somewhere distant down through a portal, we clipped what we drew inside the cell to that portal. So to that 8-sided shape. So, right, we didn't do that span processing and guarantee we didn't overdraw, but we did guarantee we only drew stuff that was almost visible because it was fit within the portals. So to the degree that those portals were relatively accurate, we were only drawing the stuff within it. There was one inefficiency there, which is if you could see into the same cell through two different portals, like two windows into the same thing, it would take the union of the bounding box of those two things. So it would draw all the stuff in between the two windows. But most of the time it worked fine. And what was nice about that was it actually let the designers make it was the one thing that was really distinct about Thief versus the Quake, because like they were very similar engines in the end because they used uh CSG building, even though the CSG was like very different, but the kinds of stuff you could create were still pretty similar. So it was CSG and it was light mapped, so it had a very similar look in some ways. But the one thing it did let them do was make object dense levels, because Thief was, you go through a manor, and in the manor there would be a table, and on the table would be a bunch of things you could steal and things you couldn't steal, and in the kitchen there would be a bunch of food objects or whatever. And uh the Quake PVS would have had to draw all the cells that were potentially visible and all the objects in all those cells. And we also had to do all the cells that we knew were visible, which was slightly tighter, but we could click to those portals. And so if you're looking into a kitchen through a window and a bunch of stuff was on a table, below with a portal, it would just get discarded. We didn't have to process every vertex. We could say, oh, that's just below the entire portal, and we don't have to
Uh-huh.
draw it at all. So Thief was able to put more objects into the level, like in a single room
Yeah.
where you could actually see the objects, you can have more objects. But in general, we could put more objects that we knew were getting culled, and it wouldn't have a lot of overhead. So that was the one nice thing about the portals, was that they did get that interesting culling effect.
Nice. Nice. And this
Okay,
is the
perspective judgment. Oh, go ahead.
and this is what
Okay.
like maybe to remind people who are listening that this is when you do this optimization, then you save either frames or you can have more objects in the current room that you are, and like this will be visible compared to other games, right? Like
Yeah.
you will
I don't know that anyone ever commented on it, but yeah, it definitely like was more object dense for its frame rate in some sense. Yeah.
yeah, yeah. Okay.
It's just, yeah, it's probably both. It both helped our frame rate and let us put more objects in, was probably the end of it. Okay, so the other topic we had was how perspective texture mapping works. And this is crazy, but it's fine. It's fun. So the whole thing about perspective, you can do a little analysis with similar triangles. Like you can look at a top-down view and use similar triangles and see how perspective projects onto a plane. And the thing about similar triangles is its ratios. Like the triangles are similar triangles have ratios between their sides. And what it boils down to is the perspective effect requires doing a division by the distance to get your projection into 2D. That's just how the math works out. There's a division. And as I mentioned, divisions are the slowest operation on CPUs. In integer. In floats, maybe square roots were slower in that era. I don't know. But so uh I think System Shock 1 was all done in fixed point math. And I think Thief was when we switched to floating point math, because the 486 had a floating point unit, as we mentioned. And so I think probably the min spec for Thief was either a Pentium or a 46. And so we switched to floats. And so there was like a 3D library that the tech group wrote that did like processing 3D vertices. So it would take 3D vertices and give you a 2D coordinate for it. So it would like batch doing the divides. And the old one was fixed point and the new one was floating point. And it would generate what we call clip codes that you needed to do 3D clipping, but we'll never talk about that. Anyway, so it turns out that when you have uh, texture mapping in perspective, every texel also needs to do a divide to compute the correct textual coordinates from the thing. So rather than interpolating U and V, if you just interpolate U and V, you'll get affine distorted perspective mapping. So the correct thing to do is to interpolate three values, effectively U, V, and depth, and do a divide, it's effectively U times depth, V times depth, and depth, and then you divide out the depth, and that gives you a perspective correct UV. And you can't actually do that, but that's what the goal is. And so people had a lot of theories about how to do that. Like, for example, maybe you could do a quadratic approximation where, because you know that as you step through, the texels get spaced closer and closer together or further and further apart due to the perspective effect. So maybe something like a quadratic approximation where the step size gets bigger and bigger would do something, right? And there were various things that people, the Yahoos on the mailing lists or whatever, were trying, but not that anybody ever shipped. Um, so Doom, which predates all these, we talked about this, had perfect texture mapping. And the reason they had perfect texture mapping is they did something special called floor mapper and a wall mapper. The idea is that uh, in perspective along the floor, a single horizontal span of pixels are all at the same depth. That's just how the math works out if you're looking perfectly parallel
Yeah.
to the floor. If you can tilt your view like at it sideways, it doesn't quite work. Actually, if you tilt your view forward and down, it actually still works, but that that doesn't help for the other case. So because of that, because the depth is actually the same across the whole thing, you can just interpolate U and V, and you don't have to worry about the depth, and it just works. So Doom was able to do the simple fast case on the floor and have it work. And so they didn't need perspective divides every pixel. And for walls, if you scan them vertically, it turns out, again, if you don't tilt and the wall is perfectly vertical, uh, and actually because of you only actually have to scan U because the V changes with depth, but only the U change or vice versa, depending on how
Yeah.
you do it.
Yeah.
Unless you allow rotating the texture on the wall. Like, so they actually had a very fast path for the wall mapper, and then floor mapper, because you could turn your view, the floor texture could rotate, and they still had to interpolate both of them. All right, so that's like the basics of how this stuff works. So, what did various people do? I do not know what Descent did. I know what Looking Glass did. I know what Quake did. So, at the time of System Shock, Looking Glass did the crazy thing that somebody had written up somewhere, and I thought nobody ever did. And then when I was interviewing, I looked at the screen and it's like, I bet you're doing blah. And I was right. I might have been wrong in my reasoning, but it definitely like helped me get the job because I was able to just look at the screen and go, oh, you're doing the constant C mapper. Um, so we just said, if the depth is constant along the scan line, you can just interpolate U and V. So it turns out if you take something in perspective at a weird angle, there is some angled line that is constant depth. Like, because constant depth is a plane, a
Yeah.
vertical plane, right? And so you can intersect that plane with some polygon, and that intersection will be a line, and that line will be
Yeah.
a line on the screen.
Okay.
So if you take this polygon on the screen and instead of scanning it out in horizontal rows or vertical spans, you scan it out along diagonals, and they're all parallel. They're all parallel diagonals, exactly parallel to each other, but they stair step as they go. If you do that, you can just interpolate U and V along that thing.
Okay.
Now they do stair step, so it's not accurate. It's not like perfect, but it's like close enough. It does produce little artifacts because you're stair stepping, not actually scanning diagonally. And so it produces little wiggly nudges, which is what I saw and said, oh, I bet that's a constant Z mapper. That was what System Shock did. It's not very fast, and it has horrible problems with uh watertight getting the fill rule to match, because the way you get a fill rule to match normally is you draw all the polygons with the same, like, we draw all horizontal spans. If you draw all horizontal spans for all polygons, then the rules that you use to trace the edges are the same, and it'll all always work. But if you have a floor mapper and a wall mapper and you're mixing them, you can actually get problems because they use different. You can try to make the fill rule match, but it won't be perfect because you're
Yeah.
scanning the edges differently in the round off error and stuff, or rounding error, floating point rounding error. Doom avoided that problem because Doom actually just drew the walls and filled in where the gaps were between walls. The way the floors got drawn didn't ever get scan converted. Didn't So they just like what pixels didn't get covered by the walls, draw those. Um, so System Shock and Terra Nova used this crazy diagonal scanning thing, and it just had to overdraw. Like it just drew all the edges too much or something. I don't remember the exact. So Quake, they figured out something very clever, which was that the floating point divide was not very fast. I don't know how long it took anymore. Uh, 30 cycles probably, right? Because it's a 32-bit number, so probably something like 30 cycles. But there was a weird quirk of the Pentium, which is that floating point operations, or at least the floating point divide, could overlap execution of integer operations. So if you and normally like a floating point add would only take a couple cycles, so this wasn't like a significant thing. But basically, you uh x87 floating point didn't exactly have registers because it was stack based. Hey, we're back to stack based again. So uh you would say, you'd push the two. I don't remember exactly how it worked. I guess they were pseudo registers. So you had FP0, FP1, or whatever. You would get the right values in FP0, FP1, and you say FDiv, and it would divide the top two members of the stack. But you didn't specify a register where to go to or anything. And so it would start that processing, and you could actually do as much integer processing as you wanted. If you ever did any floating point, it would block waiting for the floating point divide to finish. So you needed to do two divides, but they were divided by the same thing. So you could do a single reciprocal and then two multiplies. Right. You compute one over, you wanted to compute A over X and B over X. So you compute one over X and then multiply that by A and
Okay.
multiply that by.
Okay.
So Quake did this thing where every 16 pixels, it would compute the correct perspective correct UV, which required a divide and two multiplies. And we do that every 16 pixels and then linear interpolate within them. And because you're linear interpolating 16 pixels, the math to compute the step size is a divide by 16. So you switch to fixed point, and a divide by 16 is a shift by 4. So you could compute the step size very quickly. So the only thing that was slow was computing the divides every 16 pixels. But what you would do is you'd compute the correct perspective correct UV. Well, you knew the perspective correct UV here from elsewhere. You would compute the perspective correct UV for this one, and you had to wait for that. Once you had that one, you would start the computation of the next perspective correct UV, which was going to take 30 cycles, and then you would scan out 16 pixels to that one and actually compute them. And once you got here, this one would have finished, the divide would have finished. So you start the next divide and you do that. So they overlapped all the divides, didn't have to pay any cost for the divides. You had to pay for the cost for the multiplies, I think. Vague memory of this. And they did that every 16 pixels, and it was good enough. Like, the System Shock one really was correct, except for the wiggly stair steppiness, because it really is true that on every diagonal scan line, it's the 16 pixel thing isn't perfect. Nobody really knows about this anymore because nobody looks at software rendered Quake anymore. But if Quake, you stood next to a wall, like parallel to it, so you're looking down along it, so it's good, really shrinks into the distance, you would see a little swirliness as the 16 pixel affine wasn't perfect. But most of the time you could never tell. Like you really only got into those rare situations. So I knew that was how they did it. They might have published that. I don't even remember. But so I did kind of the same thing for Thief, but I did it every 8 pixels because I didn't like how the 16 pixels looked. Which is a little more expensive. I think, because maybe the divide wasn't finished by the time you got there. But uh, then for very big polygons, and I know that this was a good choice because once you have a lot of polygons, none of them are very big. But if the polygon was very big, I actually computed perspective correct on an 8x8 grid and interpolated within entire 8x8. So they were computing at every 16 on every scan line separately, right? So every 16 pixels that they output, they would have to compute a perspective correction. And on big polygons, I only had to compute perspective correction on every 64 because I was computing on an 8x8 grid, only on the corners of the 8x grid. And that was still higher quality looking than the 16. But it only worked on polygons that were big enough to that 8x8 made a difference. Like, because you still, around the 8x8s, you still had to do perfect, you had to do per scan line and stuff. And then that covers, I think, everything about the perspective. And that's all of the methods that I know of that anyone's ever used. The other thing that I did was, gosh, let's not even talk about it because there's too much stuff.
When you say wait for
I'm not
divide,
hearing it. Oh, that's probably me. Hang on.
1, 2, 3.
Yeah, probably my headphones timed out from
Okay.
not hearing anything because you were silent the whole time.
When you say wait for divide to finish, you mean, first of all, you mean assembly, right? Because like in C.
Yeah, so this is all assembly.
Okay. And
And
then,
the waiting isn't actually waiting. You just when you execute an
yeah.
instruction that uses the results, the processor would stop and wait for the divide to finish.
Okay. So we just keep going and then ask for the result. Use it later.
Yeah.
Okay.
Yeah.
Okay. Wow. That's low level.
Yeah. No, and that was so that's a part of my weird development history. So yeah, but it was also common to everyone then. Like, and certainly like Carmack, is that we were doing this crazy low level stuff, and we are doing like CSG, like geometry, like super high level mathy stuff. So
Yeah.
very weird.
Yeah. So is this the this is the wrap up for the good thief graphics now?
I believe so. Yeah.
Okay. Okay. I want to ask you about you leaving for doing the research and coming back and then leaving and then coming back. What did motivate you to do the research? Like it seems like you were driven to like kind of find this stuff and like explore it. And you left, you mentioned some management issues and then came back to finish.
Yeah. I mean, I feel like it was it is so long ago, right? I feel like it was both. I feel like I spun it as being research, but in reality, I was more frustrated with
Okay.
management. That was more of the issue. But basically, I was going to do the research no matter what. And the problem is that, like, I think there was some degree to which we needed to ship the game. And of course, that curtailed my research time, understandably. Um, and so there's some extent, I'm sure, to which I was like, well, if I just quit, then I don't have to contribute to shipping the game and I can do the research. And it literally meant I went and did the research and then came back, rehired at Looking Glass and handed them the research to use. Like, they just didn't have to pay for it.
That's
Like, so
that's an investment, you know.
it did benefit them, like, in that sense. It did hurt that I wasn't there to help ship the game. I mean, I did help ship the game, but uh yeah.
So
Um
how long were the research breaks then?
I really don't remember.
Okay.
There was probably 6 months or a year or something, but I honestly don't remember now.
Okay.
Uh, and I don't even remember how long what the time I came back and then left again. I don't even remember how long that was. Was that 2 weeks or was that a year? I don't actually know.
Okay. Okay. Now, at some point, Looking Glass is no more.
Let's do a little bit more Looking Glass before.
Okay. Okay.
So one thing I wanted to talk just a little bit about Thief. Even though I wasn't really involved in it, I do want to call attention to some technology in Thief that
Okay.
I didn't do, just because it's like, and we won't go into much detail because I didn't work on it, but I do want to like kind of call attention to it. So some of the things that Thief did, Thief had what's now called an entity component system. It had basically the first one in games. We didn't publish it very much. We didn't write papers on it or whatever. But it was so the high concept is that we in our older games we had arrays of objects, and objects would have like a type or a class basically, and so there would be separate arrays for each type that had all the parameters that that type had, and we wanted to give the designers more flexibility and more freedom. So in Thief, we created properties and you could attach any property to any object. And so the way that works at core is that the object, there's no struct or class representing each object. Instead, each object is just an identifier. It's just a magic number. And then uh, a given property like the position and level um, is actually a data structure indexed by object identifiers. And that index might be, it's an array indexed by object identifiers, or it might be a hash table because it's sparse, or it might be something else. Like we actually implemented a whole bunch of different strategies for how to store them. Do you need to be able to iterate it? Do you need to, let's look it up randomly, blah, blah, blah. And so there were a whole bunch of ways of representing properties. And so uh, but most of the time, like kind of the classic thing is that you would pick some property and iterate over all the objects with that property and do the processing necessary for that property. So that was like an important development. Like John Blow has publicly said that it's a terrible idea or whatever. But the reality is when you have a team of designers and you're trying to enable those designers, like having this flexible property scheme is useful. And uh implementing it with an NA component system just makes a lot of sense. So wanted to mention that. Let me check my notes, see if there's at least one other thing I wanted to mention, but I didn't write it down just now. So unless I already wrote it down, um, deep texture mapping. Oh, there was some texture mapping stuff we didn't talk about, but we'll skip it. Uh, uh, no, I didn't write anything else out about Thief. So what's the other Thief thing? A Thief had a sound propagation system that meant sounds didn't travel through walls, they traveled around through corridors. Almost no game has done that since, seems like. That was
Mm.
very important for that stealth gameplay so that you, like, knew which direction a guard was, you could hear them coming, uh, because because in most games, it just was like, "Where is the sound source in 3D? What's its 3D
Ah,
coordinate?" And that's the direction you hear the sound from. And in Thief, we, like, said, "Okay, here's the sound source. Where can the sound can come from these 2 different directions, but this one's the shorter direction, so we'll have it come from that one," or something like that.
okay.
Again, I didn't work on it. Um Oh, there's the whole paper I wrote about this back on the graphics. There's the whole paper I wrote about how the sorting works in uh, Thief, which was very complicated because it's the painter's algorithm, but it's well known
Yeah.
that the painter's algorithm has various problems. So I wrote an article about that. But one of the fun things was that once you put an object into the scene, you now need to figure out how to sort the object relative to stuff. And you could have like a niche, like you had a corridor with a niche and an object crossing into the niche. And that meant that the wall in front of the polygon needs to front of the object needs to hide the back part of the object that's inside the niche, but the part that's sticking out needs to hide the wall that's further away. And that was
Okay.
not natural to do. Like it sounds easy. Oh, well, the objects like it's clearly sortable. The far wall than the object than the near wall. But the problem is if all of that was one big cell and we had no sorting of within the cells, it didn't work. And there were other complicated cases like Quake's water was opaque, like it was this swirly, muddy surface, and so you had to go through it to see underneath. But Half-Life and Thief had transparent water, so you could see a character standing above and below the water. And uh, Half-Life was based on Quake, and Quake had a Z buffer, so I assume that that worked by drawing the object and then drawing the water through the Z buffer, and which does what it happens with graphics hardware, which causes the transparent water to you know, shade the underwater part of the thing and not the top. But in Thief, we just had sorting, and so if an object is partway through water, like, it won't do the right thing. So we use something called user flip planes. They exist in modern graphics hardware, but this was just in our tech library. I asked, or they had already added user clip lanes. And clip lanes are when you have to frustum call. So you're looking through the
Okay.
screen. The
Okay.
screen, screen forms a pyramid in 3D, but the edges of the screen form a pyramid. And when you draw a polygon, your polygon has to get clipped to the edge, like my hand is getting clipped. And you actually do that in 3D space by clipping against that frustum plane. And so you add an extra plane. So when a guy is standing in water, we drew him twice with a user clip plane, one pointing up and one pointing down. And so we drew the top half separately from the bottom half so it could be drawn correctly by the water. And the torch sticking out of the niche actually just did the same thing. There was a portal through at the edge of the niche to at the boundary of the niche and the corridor. And so that portal became a clip plane, and we drew the torch twice. And so the part that was inside the niche was got drawn first. We drew the niche first because it's on the far side of the portal. So we draw the niche, draw the part of the object inside the niche, then draw the corridor and the part of and that fixed the sorting.
Yeah.
So yeah. Anyway,
S-
there was some other. Oh, I know what the other tech thing I wanted to mention.
Yeah.
That's just not. That's just not okay.
Okay.
It's fine.
There are so many things. So many
Yeah,
things in
exactly. And
this.
since I didn't work on them, I figure it's better to skip them.
Okay. Okay. This is crazy. This is crazy. Like at this point, there are so many things figured out that it's just,
Yeah.
but this is why they are figured out, right? Like this is the Z buffer stuff. Like this is somebody needed to do it first, and then it was
Yeah.
like,
Well, and the thing is, we knew about the Z buffer. It just didn't seem efficient. And, Quake went ahead and did it and made it efficient. But I don't think it would have been efficient for us. Don't think if we had tried to put a Z buffer in, it would have worked.
okay,
I mean, it would have worked. It just wouldn't have been efficient.
okay.
Would have been slower.
Um,
I mean, that's the thing. The Z buffer was invented probably in the 70s or the 60s or something, but it's just, a very expensive uh
in
extra thing.
in Looking Glass, after Thief, you also worked on next games, right?
So I added colored lighting support to the Thief engine for System Shock 2 or for Thief 2, I don't remember which. And then we didn't ship anything else. I was working on other stuff. We were working on was effectively the next Thief engine, but the company shut down before we got
Okay,
very far with it.
okay. What happened for you then personally after Looking Glass?
Looking Glass shut down. So during the Looking Glass times, probably when I was unemployed, when I'd quit, I actually semi-interviewed at both id Software and at Valve. But I don't think id Software even made me an offer. Uh, and the Valve was very informal and I didn't follow up on it. Um, I think when I interviewed at Valve, actually, it was very early. It was like, because there was a whole thing with Half-Life where they decided to take another year or another 2 years or whatever it was. There was a thing where they were like, "This isn't good enough. We can't ship it. Let's stop and spend another year or whatever." So it was before that happened, and I looked at it because when I interviewed and I looked at it, I was like, This doesn't seem great." And it might, and again, that judgment might not have been based on the same issues. Like maybe I wasn't actually seeing it correctly, but by coincidence, I happened to be able to. I don't know about that, so I didn't pursue that. Again, I don't know if they would have been interested anyway. But so I had already done that stuff by the time Looking Glass folded, and so I was like, well, I could go back to looking at those companies again. And what I decided instead to do was go indie. So I moved to California, where uh, a guy I knew, Chris Hecker, who in this story most probably figures as co-founding the Indie Game Jam with me. Uh, Chris Hecker was a former Microsoft employee. He at that time maybe Oh, I kind of had gone and semi-interviewed with it. Oh, that's why I was there for Valve. It's because I was also kind of interviewing with Chris's company back earlier, which was, I think, when Casey was there.
Okay.
So Chris and Casey had a game company that they were doing at some point, somewhere in this history.
Okay.
Uh, probably in the 90s, but gosh, I don't count. Maybe it was later. But I think by the time moved there in 2001, Casey had moved on. Maybe he was at Rad. I'm not sure. Uh, when I moved to California, and Chris was renting space in a barn. Wasn't really a barn, but it was a barn-shaped building. And I sublet from him, or maybe he let me work there for free. I don't even remember now. And I tried to be an indie game developer. So from 2001 to 2008, I was an indie game developer, an unsuccessful indie game developer.
You worked then on Chromatrons?
Yeah, so what happened was I tried to work on bigger games like that hover tank game that I mentioned, and like an RPG, a kind of Ultima Underworld inspired RPG. Um, but also I would occasionally make a little game like in a weekend. And we started doing the game jams, which were weekend games. And I could finish a game in a weekend, or I could get enough of it done in a weekend that then I could polish it for a week or whatever and ship those. But I never managed to ship a game that was larger scale than that. The only games that I ever managed to ship were kind of weekend sized games. So I made the Chromatrons, which were little puzzle games involving bouncing lights, lasers off mirrors. And then I made a couple other little games that were even less substantial. Like I actually charged money for the Chromatrons, but not, I made $100 kind of charging
Okay.
money, and if it's just released them for free.
Okay.
Maybe I made $200. It was very unclear how to be an indie game developer in that era, because 2008 was like the year that Braid came out. So 2008 was sort of the golden era of indie game development, and I was in the 2001 to 2008. So there were successful indie game developers then, like Jeff Vogel of Spiderweb Software, who makes the Exile RPGs. I don't know if you've heard of those.
I've seen them, yeah.
So Jeff Vogel, random connection, was also uh, a participant on Talk.Bazaar, the Usenet news group,
Oh,
where
really?
I knew Dan Schmidt, Dan Schmidt was the person from Looking Glass who I knew, just to mention what his name is. Um, so yeah, Jeff, and Jeff's games occasionally had little Talk.Bazaar references. I don't think I ever showed up in it, but he did have, like, he would name a character after a personality from that news group.
Okay.
Anyway, so yeah, but yeah, so there were successful indie game developers, but there wasn't like a clear path or anything, and I never figured it out. And I was not very good at being an indie game developer. I had a lot of trouble motivating getting finished. I would too easily flit to a new project. It's like a common problem. I mean, a certain class of people who aren't successful indie game developers. I would too easily just like, let me do this other thing instead. Oh, let me do this other thing instead. Whereas if the game only took a weekend to do, obviously I could get it done and finish it. Um, so yeah, so I did the Chromatrons for money, and then I did occasional other little games. But obviously the big thing then is the Indie Game Jam and then the SB Libs, I think, are the next two topics.
Yeah, I think we can start with indie game jams because they're already mentioned. How did that
Yeah.
happen that, the idea came about and then so many people in the indie game dev area joined?
So, I mean, basically, it was a technology first thing where it started from us saying, if you, instead of using 3D models, if you used sprites, if you used single quads for a character, how many could you put on the screen? And because there were games at the time that were doing this, specifically Shogun Total War. Now you can read the Indie Game Jam Zero webpage. It talks all about this. But Shogun Total War had maybe 1,000. And we were like, you can definitely do more than 1,000. I think Casey was around. I don't know why Casey was around if he was at Rad. Maybe he wasn't at Rad. Uh, but I remember Casey was around, and we were kind of tossing that idea around, and we were like, you have to be able to do a whole bunch. Um, and I don't remember how we got from that to doing the game jam. But somehow we were like, we said, well, what if we made an engine and the engine does 100,000 sprite guys? And then we turn a bunch of game developers loose on that engine for a weekend. What happens? I do not know how we came up with that idea. That was like somehow that idea came up. Chris and I are credited as the co-founders. So it's clearly a discussion between the two of us, but I don't know how exactly that works. I wrote most of the code, I'm pretty sure. So maybe most of the idea was his, but I might have been an equal. It's really, really faint memory. And Casey was around, but I don't think he contributed to that part of the idea. I think he was contributing to that, the high concept of the 100,000 guys. But really, it preceded technology first. It was, what could you do with 100,000 guys? And we're like, well, what could you do with 100,000 guys? Well, let's ask about, I'm hypothesizing here. It's like, well, let's ask a bunch of other people. Well, let's not just ask them, let's have them do it, was sort of the pitch. And the idea, I think we knew that because we were indie, but we kind of knew that, like, yeah, maybe these other people who are in the industry would like that experience, that just spend a weekend just getting to like, they don't have to deal with, you know, uh, code review or, I don't dealing the whole thing of dealing with the other people at the company. But that was sort of the pitch. And it turned out to be true. We brought in a bunch of people we knew. I think almost all of them were people Chris knew. I mean, I knew some of them as well, but I think he was in charge of the invites because Chris Hecker was just a guy who had all the connections in the industry. And that was just one of his, like, the things that was true about him. So I think he kind of came up with the list. And uh so that's where it came from.
Okay. Was this in his barn?
Yeah. So that was the other thing, is we had that space because we had the whole upper floor of this barn. And so there was room, you can look at the pictures. There was
Yeah.
room for 16 people or something. This was in an era before everybody had a laptop, before you could just count on everyone to have a laptop. So we actually wanted to have desktop machines, and somehow Intel agreed to supply
What?
16 desktop machines for this. Like, so Intel sponsored it. Um, I wrote this engine to draw the 100,000 guys. Uh, I think it might have been OpenGL even. Gosh, I don't remember whether it was using OpenGL at that point or what the whole state of Direct3D was, but it might have been using OpenGL. And the reason I think that is because I'm pretty sure it used immediate mode to draw them. So immediate mode is this thing where you say you're down in the code and you want to draw a quad, and you actually just say, well, in this particular case, you wrap the whole 100,000 guys in, I'm going to draw quads. But when you get to the guy you want to draw and you say, okay, here's this first vertex, and you call a function to say, here's the texture coordinates for the vertex. Here's the two separate function calls. Here's the coordinates for this vertex, and here's the 3D position for the another function call. Here's the etc. Did all that. So there's this big loop. So the whole thing was inspired by particle systems, right? So a particle system is something where you have really simple little things and you can draw a whole bunch of them. And so that was where that idea kind of came from. It was like, well, you can draw a lot of particles, and how much harder is it to make them be guys instead of particles? It's not that much harder. Um, and so the uh, the inner loop would do some amount of processing on each character. I don't remember what, but like they probably had a velocity and a position. And so in this one loop, we would update their position based on their velocity, and we would draw them in the same loop because it's in cache now, and so you might as well do it. Anyway, so did that in immediate mode, wrapped in I'm drawing quads. And then I was like, okay, well, like, that was just the first proof of concept. Let me now do it correctly. You had to use crazy things to get the thing into VRAM on the GPU. You like vertex array range or something. And let me do this thing correctly, and I'll build a buffer. And I don't want to write it directly into VRAM because that's actually slow due to something right combining didn't exist yet. And so I'll do it in little groups. Every 32, I'll build 30, a little vertex buffer of 32, and then copy it into the big VRAM vertex buffer. Do that, do that, do that, and then draw all of them. So I wrote all that code, and it wasn't any faster because the NVIDIA drivers at the time took those function calls and generated code behind the scenes, like literally generated code so that when you call GL vertex, it just stored it into a vertex buffer in the format that it knew it needed. That's why I had to generate code, because they had to decide what the format was and what the spacing was or whatever. And so it was already basically doing the exact same stuff I was doing, just automatically behind the scenes. Like they were crazy what they were doing in those drivers to make that kind of stuff fast. So it turned out like just doing it the dumbest way was just as fast as doing it the smart way. And then, so the reason that I brought this all up, talking about the Intel sponsors, is because we actually got a visit from one of the P6 designers, Andy Glue, came and visited. I don't know if it was related to, like, maybe we, like, probably the way we got the sponsor was that Chris knew somebody at Intel and asked that person, and that person managed to pull the strings to make it happen. Maybe it was Andy Glue, maybe it was somebody else. I don't know. But Andy Glue came and visited. And so I kind of like, he came and visited with the pitch of he would help optimize our code so that we could get 100,000 guys. But I think he didn't actually add anything because it was already good enough. And like his insights didn't help because of dumb stuff like that, where it was already fast because NVIDIA had made it fast. But so the thing was, is that gave us a uniform thing. We all had the exact same desktops with all the exact same graphics cards, and we could render, I think it was 35 frames per second or 30, like maybe there were 70 hertz monitors, so it was 35 frames per second, or maybe it was 30 hertz. I don't remember. But I believe we could push 100,000 guys at 30 hertz was where we ended up. And the way that worked was that we did some of that processing for every character, like the updating the velocity. They ran along on a height field, so we had to check the height of the height field and make them stay on the height field. But some of it was stochastic. So the collision detection between all of the guys, they were split into buckets, and I would only process
Yeah.
buckets every 4 frames or, some kind of thing. So I didn't have to process all the buckets. So when they were collision detecting, they might be a little late in collision detecting, but because they were sprites, they would like, one would be in front of the other. Like you wouldn't see guys go through walls because we didn't have that kind of environment because it was a height field. So you didn't have so many walls, and they wouldn't go through each other because they were just sprites. So it wasn't so bad, and people could write whatever they wanted. So people didn't have to use the that collision detection scheme. I think I implemented flocking, so by default you could get a sort of flocking behavior or whatever, but everyone just implemented whatever they needed as their logic, but still managed to generally stay at the same frame rate most of the time
This was
because we were bringing in technical people. We were bringing in designers mostly with programming skills.
yeah. But the idea of the game jam was that you provide the computer with the software to render 100,000 guys running on a height field, and the contestants or participants, they can do whatever with it.
Yeah, exactly.
Okay.
Yeah, and it's definitely not a contest. It was like, that's why it was called a jam. It's
Okay.
inspired by music. In a music jam, you're just getting together and jamming.
Oh, okay.
And so, right, there was no winner. There was no, like, it was supposed to be collaborative. People could help each other out. I made a game very quickly. No, not that quickly, but I made a game in a couple days, and it was a 4-day weekend. And so then after I made my first game, I went and helped out a friend of mine, former Looking Glass employee, on the game he was working on. Although that one it wasn't great. I don't think we ever got it into a great state, but there were a couple really clever games that came out of that. Like, that you could, in theory, have polished up and like turned into a real product, although nobody ever did, because again, that was not the era of indie games being super successful, and they also were all employed at real companies that probably wouldn't have let them do it anyway.
Yeah. So how
But it
was
was a big success. Like, there was definitely, it was either that one or a later one that I remember somebody, gosh, I can't remember who it was, but I remember somebody came and was like, "Oh, I do know it was Ottman Binstock at the probably the second one, who was like had kind of gotten burned out on the gaming industry and was leaving it or thinking about leaving it or whatever, and they came and did a game jam. I was like, "Oh, I'm staying in the game industry." So that's like a big success. I mean, okay, I may be exaggerating. That's my memory of it. That maybe my memory is slightly exaggerated or something, but I really remember it, that feeling like it really changed the direction he was going. So, even if we never shipped any games that like were playable, there was because there was an whole unfortunate thing of that we used the Doom assets, so we didn't have the right to ship the assets, and so nobody ever got to play any of those games. But
Okay.
we were supposed to open source the code, and you could have your own copy of the Doom assets, but then Chris Hecker never got around to solving the source control and releasing the code, so the code never got whatever.
Okay. Okay. It lasted. Do you remember how many game jams were there? Indie game jams.
And there were 3 or 4 in consecutive years, and then we, like, missed a year or 2. But so there was the first year was 100,000 guys.
Second year was the
Second,
light.
Shadow
Yeah.
Shadow Physics, yeah, which was based on Zach, what's his last name? I don't remember his last name. He had worked at Origin. It was he had done like an art project in using the light projectors and the casting shadows and light projectors. And so then he kind of shared that with us. And so everybody was developing using like a simulator and then could run and test on the real thing, but we didn't have like 10 real things. We had one real projector to run the games on. The third year there was a physics engine, a 2D physics engine, which was novel at the time. Like that was before engines all had like decent physics engines. So I believe that was Ottman's physics engine. Um, and then that might have been it. That might have been the last one where we did them consecutive years. Or there's one and I'm just not remembering it.
Okay. Okay.
And then, but whenever we did it one, there was like a sound one, I think. Don't remember, but I think that was more themed instead of tech. Whereas like those first 3, I let's just bring up the site just in case I just want to forget it. Indie Game Jam. What's the name of the site? No, I don't know. I don't know what to search for. Oh, there it is. Okay. I use it. This only has 2 on the site. Uh, yeah, there was a physics one that's not on the site. Uh, oh, it is on the site. It's just not linked from the page I was on. So
Yeah.
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 So yeah, we did 3 years in a row, 2002, 2003, and 2004.
All right.
Go ahead.
What happened then professionally for you? Because you moved to California, you tried to do indie games. It didn't pan out. You were doing the indie game jams, but this was like once a year event.
Yeah.
What happened next?
Yeah, and so after the indie game jam stopped, I continued to do like my own personal jam. I would try to get a weekend game done once a year or so, to some extent. They're all on my website, but uh, so then uh, I I was also at the same time I would do contract work for like 3 or 6 months every other year just to have money. Um, but eventually I was like, okay, like this isn't working. I can't ship a game. So I need to do something else. And so I was like, well, I can go work for a game company. I'd like to make games. I like making games, but I've been a solo programmer for 8 years and I've gotten really used to that. And I've started developing the STB libs, which we can come back to, but that had already started at that
Oh,
point.
okay.
And uh, I couldn't picture working on a team of like 20 programmers because I knew the kind of frictions that you would, because I started having those frictions at the end at Looking Glass, like the friction of, just you're not your code base. You don't control it or whatever. Um, and I knew I wouldn't, so John Carmack kind of didn't have that problem. Like he got to rule his code base Like he got to do it his way. And maybe by the end that wasn't true. I don't know. But um I definitely didn't have that option at Looking Glass. And it wasn't clear that there was anywhere that I could go where that would be true. It was highly unlikely. And so the best I could hope for was like to find somewhere where there'd be 2 or 3 programmers. And I wasn't seeing anything like so that I could still reach some level of efficiency because I knew part of the problem is that if I'm on a team of 20, I'm not hitting the speed of output that I can hit. And so my morale will not be good and I'll want to quit. Uh, so I kind of looked around and I didn't see a lot of options. And Jeff Roberts from Rad probably had already been pitching me. I don't remember for sure. But uh, because I'd already started doing the STB libs, he actually hired me to do Vorbis. I did STB Vorbis for Rad a year or two before this. He offered me some amount of money to do STB Vorbis. I was like, I'd like to open source it. He's like, well, I'll give you half as much if you want to open source it. Or you can get the full amount and open source it in 2 or 3 years or something, something, I don't remember. And I was like, "I'll take half." And I made him the SVG Vorbis the way he wanted it and also released it publicly at the same time. And then I think about a year later was when I said, "Okay, this ain't working. Let's find a place." And Rad, because he had already pitched me on it, so again, like, this is not me looking for a job, this is me being offered a job. Um, one of the things I knew about how Rad worked was that Rad had a bunch of separate projects, and each project had one programmer. And so if you were the programmer on the project, you got to control how the code worked and what it was. I should point out, when I was at Looking Glass, I was using C++. And when I back at the printer company, we were using C++. So I wasn't unfamiliar with C++. But during those 8, 8 years from 2001 to 2008, I had moved away from C++ back to C.
Okay.
So, uh, so that was another thing. It's like, I'd rather program C. I would go work for a company that did C++, but I'd rather do C. And Rad, it was just owned and run by Jeff Roberts. Jeff Roberts was also only programming in C. So I knew if I went to Rad, I would get my own project. I could make the code feel like how I wanted. So I'd always be able to work at max productivity and not have morale problems. And it could be in C. And I knew he was friendly to the open source thing and potentially anything I wanted to open source that I was working on there, I might be able to open source. So it's like, that's kind of a no brainer. Uh, I thought I would just work there for like 4 or 5 years and make some money and then go back to making games. But instead I stayed, um, because like it wasn't clear that I still would have the same problem if I went back to games of would I ever be able to finish a game on my own or was there a company I could go join? Wasn't really clear. So I stuck around for longer. Uh, but so that is the answer to how did I end up at Rad? I don't remember what question you actually asked.
No, no, no. This was the question. What happened
Okay.
after the indie game
Yeah.
jams? But then,
All right. So now let's rewind to the talk about the STB libs. So is
yeah,
that
yeah, yeah, yeah. But for how long did you stay at Riot exactly? Do you remember?
I started in 2008 and I just left this year. So
Okay,
17 years.
okay,
Jesus.
okay,
I should have quit as soon as we got acquired by Epic because that I no longer was in that role. I mean, I wasn't in that role anymore before that for various reasons, but um I
okay,
was no longer like the sole programmer in charge of my code base. But also Epic was just a big company with a lot of friction. I was isolated from almost all that friction. I was working on rad stuff at Epic, so I didn't really have directly feel that pressure, but it just the whole experience was a little weird. Um, we had gone to a 4-day work week at Rad, which was really great. A 4-day work meaning 32 hours a week, not
okay,
meaning like, it's a very nice, luxurious feeling. And when we went to Epic, we switched back to 40 hours. So, just, I probably should have just quit right away, but I stayed on for 4 years or whatever.
okay, okay. STB libraries. When did they start
Yeah.
and why?
So one of the indie game jams, wait, I do know one that we left out. There was the indie game jam that we did using Sims assets.
Using what?
Uh, Sims, the Sims assets. We
Oh,
had 3D,
okay.
we had all the 3D models from the Sims. And we had an engine that had pathfinding and a simple 3D renderer. Gosh, I don't, and we didn't do it in the barn. We rented a space in downtown Oakland. Uh, and well, I don't remember any games that anyone made at that. Um, gosh, that was so, yeah. I don't know if that was, but it was still, so it was sort of technology driven because it had a premise of, the premise wasn't make a game about characters. The premise was make a game with these characters. So it was
Okay.
kind of still not exactly technological, but still, but anyway, so in that engine, uh, the graphic stuff was something Chris Hecker had made that was a C++ library in a header file. Now, in C++, you can put everything in a header file because you can put a class in there and put the definitions on the class, and it's not unusual to have everything live in a header file in that sense. But it was a single header file. And that was when I noticed the idea of a single header file library. So then I had to invent, quote unquote, invent the idea of doing it in C because you don't have that kind of automatic inlining stuff. So you need shenanigans to make it work. Um, but the first library that I did was ftb.h, which was just my personal fragments of stuff that I was reusing. And I don't think I even intended to open source it. It was just me trying to find a way to make reusable code. But I do remember, and if you look for things online where I've talked about where did the SCP libs come from, you'll find a bunch of different explanations, and they're all true. But one of the things that happened was like at Looking Glass, I made a couple small libraries for myself to do some simple things, like sort of like a profiling library or something. Actually, there was a coverage testing library, which a coverage tester tells you what lines of code have been executed in your program so you can discover if you've missed, if your test suite doesn't cover everything or whatever. And I'd written a sort of thing like that. I think I wrote it for uh the polygon sorting that we didn't discuss because I had a crazy polygon sorting algorithm that had a lot of cases and didn't really understand it. Had gotten so complex I didn't really understand it. So I think I wrote the coverage tester so that I could make sure I I was testing all of the paths that because it had so many paths.
Okay.
But but so what happened was I was like, that's really annoying. If I want to use one of those things, I have to write it again. I don't want to write it again. I already wrote it once. That's annoying. And so I thought to myself, well, if I make something like that that I write be public domain, then I'll always be able to use it. Now, why a company I'm working for would let me make it be public domain was not a problem I tried to solve, but that was my thought process, even if it doesn't really make sense. Um, and so that's why then when I started actually making libraries, I put them in the public domain. The idea was that they were really for me. They weren't for everyone else. They were for me so I could use them in 10 years. That was sort of that's one of the many explanations. Um, but so stb.h was the first one, but it doesn't really count because it was really just for me. But it was where I figured out the dynamic array thing, which I think is one of the most important things I've come up with. Um, Not a reinvention. I haven't actually talked that much about how I keep inventing things people have already invented, so it doesn't really care. I haven't talked about that much, but I did do that a lot. It turned out the whole thing with making a C header file library where you have to define a special thing, and that causes the implementation to be generated, and you only put that in one file. I much later found out I found a header file that did that. It was a single header file and it had a thing that you defined that caused it to generate the implementation. And it was Microsoft had a file. So Microsoft had an API for doing multiple monitor support. And there was a header file that had like simulated multi-monitor support or something. I don't remember exactly what it was, but it's multimon.h or something like that. And it was exactly that. There was a pound define that you defined to generate the code. And it was like from 1998 or something, like 10 years before I did it.
Okay. Damn it.
Anyway, so it turns out I keep reinventing stuff. Like I invent something and it feels unique, but it turns out it wasn't actually unique. Somebody else already did it, but whatever. I popularized single header file libraries. That's how I put it in my bio or whatever. Anyway, so the first real one was STB image, and STB image is, and because of that, that's why there are multiple explanations for this, because there are specific reasons I did STB image. And some of those reasons are as follows. The PNG library, okay, a lot of libraries were really oriented around Linux. Linux has a stable standard place that when you compile a library, the library goes and lives in this directory. Windows didn't have any standard development thing because Windows isn't a developer-oriented platform. And so I would always have this problem when I would set up a new machine and I would be like, okay, like I want to load a JPEG. I don't have the JPEG libs anywhere, like, or they're somewhere. I have to do it, and where do they live? And then I have to configure the Visual Studio to look in the right spot. And I was just kind of tired of that. And I was like, well, if I did one of those header file libraries, then I could just copy that into every folder that needed it, which is kind of dumb, but it's a solution. Or I could point to that, and it's just one file that could keep around. So that's one aspect of it, was the frustration with the lack of a location for libraries. There was a related problem, which is that you would build a library, and then when you tried to link it, Microsoft used different libraries for C runtime libraries for debug and release builds. And so if you statically linked the library that you built, it would depend on either the debugger or release build, and you couldn't use it for both. You had to actually build a debug version and a release version, and now you had to set up paths so that it would link the right one, and I never wanted to do that, so I only ever had one, and so then it would, have this right. You had to I don't even remember. Okay, anyway, there was some nightmare like that. So there was that problem. So there was the where does it live problem. There was the it's built against the wrong libraries, the wrong C runtime libraries problem. There's always running into these problems. Then there was the issue that the PNG library really annoyed me. So the JPEG library, I think it was the JPEG library, had this dumb thing where they used long jump, which is this whole thing in C that's sort of like exception handling. You call set JMP, and that sets a point that's a little bit like a try. And basically it saves some info about the stack. And then you run a bunch of code, and when you hit an exceptional circumstance, you call long jump, and it unwinds the stack and ends up right back at the point where you called set jump, but you branch on it, like it returns 0 or 1 depending on whether it ran correctly or jumped back out. And so it was a way to let you accept out of a thing. And so because they were making these libraries that had all these crazy error conditions, they didn't want to propagate the error all the way out manually, so they just long jumped out. That's fine. The problem is they didn't do that inside the library. The way to call the library required you to call set jump and pass that in when you called the decoder, and then it would long jump back out to you instead of it being hidden inside the library. And that was dumb. I'm pretty sure it was in JPEG. And so I wrote a wrapper, and I would always use the wrapper, not the library, and the wrapper did all that for you automatically. Then libpng, the people who wrote that looked at JPEG and said, oh, we'll do the same thing. So it called set jump. It made you call set jump and long jumped out to you on the error. Pretty sure I'm remembering this correctly. And PNG compression uses deflate zlib to compress the raw data internally. Sure, it makes sense. There's an existing standard compressor. You use that inside your thing. That's fine. So it depended on the zlib library. That's fine. But the PNG header file that you look at to call PNG, the PNG API, that header file included the zlib header file. So again, that's all fine on Linux because you've just installed zlib and PNG and they all went to the right place. And so the PNG header file, including the zlib header file, just works. But on my system, I wouldn't have the zlib header file exposed because I didn't ever use it. So I hadn't bothered to copy it into the right place. And so I would try to run the PNG thing and it's like, oh, it depends on the zlib. I got to copy the zlib header file over. So PNG, you had to have the PNG header, the zlib header, the static lib, and the DLL, or whatever. It's a whole bunch of files. All of that's annoying. The final thing is that I had always been curious about how JPEG worked, and I had read articles about how JPEG, but I'd never written a JPEG decoder. I had been wanting to write a JPEG decoder, but I never had. And the reason I hadn't is because you had to spend $130 to get the spec from whoever, IEEE or whatever, to get the spec for JPEG to actually find out how it actually, the actual details to write a decoder for it. But as the web became successful, the World Wide Web Consortium, what W3C, started publishing all these specifications, HTMLs and various stuff. And somehow they got the rights to publish the JPEG specification publicly for free.
Oh.
So suddenly there was a JPEG specification that I could just look at and I could just go implement a JPEG decoder. So I was like, there's all this friction. There's all these other issues I've mentioned, the stupid header file exposure. I could write a JPEG decoder, see how that goes, and I could write a PNG decoder. And I wrote one or the other or both, probably just one or the other in a weekend. And probably wrote the other one in a weekend as well, probably. I'm not 100% sure. And that was S2B
Image.
image.c. STB image.c. It was not actually originally a .h. I knew I had already done stb.h, but at first it was not a single header file library because I think I hadn't realized that that would be the right way to go with it yet. But it avoided all those other problems. And it's just one file, except that you had to deal with the header file. But I think there was no separate header file. I think you could include the .c file with a special flag that would only generate the declarations and not so it was the reverse of how the STB
Okay.
how the things work now. There was a symbol that you did to say header file only or something like that, and then include the C file. I think that was probably how it worked. I don't remember though. But so I made that one, shared it with friends, put it online on my website probably, and then people emailed me bug fixes. And then I don't know when I converted to a header file. Was that after GitHub or before GitHub? It's probably after GitHub. So when did I put it on GitHub? I put it on GitHub when Jeff Roberts got married, but gosh, I don't remember. Literally, I flew to New York for his wedding, and while I was there, I put it on GitHub. So that's how I know that, but I have no idea when his wedding was. Let me just check GitHub.
You said it like almost this was the reason you put it on GitHub.
Yeah,
like it's a celebration of Jeff Roberts getting married.
How do you find out when this started?
In the meantime, for everybody who is listening and who's not aware, STB image is probably in every game engine and most like C or C++ like projects that are doing anything with loading a piece of image.
So it shouldn't be. It may be in a lot of them. It shouldn't be in like AAA games. It probably is still in some of them. Because the thing is, it's not designed to be like the best image loader. Like it's not designed to be the fastest. It's not super optimized. It's designed to be maintainable than it is designed to be optimal. And this is a thing that's pretty standard about the STB libs, is that they're designed to be easy to use, easy to integrate, right? Like easy to put into your build system because they're just a header file, so you don't have to do anything in the build system. And then they're easy I try to have good APIs. Like Casey had some good, had a good talk about API design, and I learned from that. But I also had just been programming for a while, and I would always do the thing of write code that uses the API before writing the actual library. Like I would try to find out what the right way to do the APIs. There's a huge mistake in SVG image that's remained there, and it's a source of annoying bug reports that I just don't want it. Once it was be clear that it was a mistake, it was too late. I didn't want to change that part of the API, um, but for the most part, the APIs are well designed. So easy to build, easy to call, and easy to maintain are the priorities, and not too slow. The FCB image write, for example, is notoriously slow at writing PNGs. It's a very bad PNG encoder, but the idea there was just like, if you need something, here it is. Like, but don't ship this to customers. But I never made that clear. Like, I was never very clear about what state things were in, so people may use it when they shouldn't. Oh, I just didn't even try to find the history here. Uh, what's it? How do you go back in there?
On GitHub.
Let me just go to Git. I can just do a Git log and see the whole history. Oh, except it makes me space through it. So do you have another follow-up question?
I have. First, because we were talking about open sourcing, and you were an employee of RAD then. So how did it happen that, because did RAD need to agree to release more and more STB images, STB libraries, and open source them?
Yeah. So I made SBH in, I don't know, 2004, 5 or something. I think SB image started in 2005. I'd have to do a research check. And then I went to RAD in 2008. So STB4 was already existed by 2008. And it looks like I started the GitHub in 2014.
Okay.
So that's when it got serious. Up until then, I was accepting patches by email. It was crazy. Especially because I would just get people making the same report. I would get like 20 people making the same report. And I like had no way of announcing new releases or anything. Um, so I had done STV Orbis for Rad. So, I had known Jeff for since the Looking Glass days. Not like spending a lot of time with him, but had known him. So I'm like every once a year at GDC or whatever. And so we were kind of friendly acquaintances or, like Florida friends, um, loosely friends or something like that. So there was definitely an understanding when I started. I actually don't remember, but I'm fairly sure there was an understanding when I started that it was possible there would be more STB libs coming out. And Jeff was fine with that.
Okay.
Jeff understood that if the A, it, I could do what I wanted in my free time, like that it was not like a normal, you know, you're not allowed to compete with, so I wasn't going to compete with him. I wasn't going to release a character animation library, SBA library that would compete with Granny from the Rad uh, library. But I mean, that was just, understood. I don't even think we talked about that, but that was just obvious. But stuff that was orthogonal to what Rad did, I'm pretty sure we both understood that that was uh reasonable. And in fact, I did actually open source the true type library was something I actually did for a Rad project. And I talked about with Jeff and it's like, oh, and the text editor was also that. Talked about with Jeff and it's like, this is not a um I've forgotten the language, the business language you use for this. This is not a differentiating thing. Like, this is not a thing that, like, giving this to our competitors doesn't help them meaningfully. I mean, I guess it would save them the time implementing the true type themselves, but it's not like that's not what's going to make the difference in us selling this product, whatever the product would be. And so knowing that it's very easy for Jeff to turn around and do that. And Jeff is just of that philosophy too. So, for example, one of the libraries that happened later was STB imagery size. Um, but then further down the pipe, Jeff was looking at imagery sizing and was like, this code just isn't very good. I don't like how it works. I don't like various aspects of it. And he wrote STB imagery size too, um, which, and then open sourced it, like, got permission from Epic or whatever. And, uh, or maybe it was before Epic. I don't remember now. But, um, so he was already simpatico with that idea
Okay.
anyway. But I mean, I don't know that I knew that going into it, how much that was going to be true, but yeah, because I had said that whole thing about I don't want to write this code and then have to write it again. That was definitely on my mind, and I'm sure we talked about it.
Okay. Which one took the most work?
Let me bring up the list.
STB image, TrueType, Vorbis, DS, STB.h, stretchy buffer, not named STB, oversight.
Well, stretchy buffer is deprecated, and that was actually intentional because stretchy buffer, like the initial letters do say it. Actually, that's not true. That was a coincidence, but stretchy buffer was intentionally not a library. It was meant to be like a cut and paste source. It was meant to be like you can use this code to do, which is it's again that dynamic array thing that I talked about before. Stretchy buffer was another way of doing that, and STBDS is the one that ended up being the official version. Like stretchy buffer got deprecated in favor of STBDS that
Okay.
has the really solid implementation of it. Um, looking at it, I'm looking at every single one so I can actually answer the question correctly. Um, probably STB image.
Oh, really? I thought it's gonna be TrueType. All the fun stuff with fonts and rendering.
Well, STB. So the thing about both of those is that they were largely implementing an existing specification, and it just turns out that I'm pretty good at that. Like just reading the spec and following the instructions of what the spec says. So STB Vorbis was that as well. Um, actually, Vorbis might have. Because Vorbis was a little vague. Yeah, I can't really say what was really the hardest, but I can definitely say, like, things that stick out in my memory. So one thing is that, like, the, um, STB Vorbis had, uh, some sticky stuff that was hard to figure out what was really supposed to do, but STB Image had a bunch of image formats, although a lot of those were submitted by other people. But, like, eventually I went and added support for progressive JPEGs, which are a total mess, and that was super annoying code to write, I remember. Um, and it's not efficient at all. Uh, so probably it's really not how I even think about them. It's like, often it was like, it's a need most of them are written to fulfill a need that I had. I need this thing, I need to write this thing so to fulfill this need, and it will take however long it takes to write. But, like, to so rather than thinking of length of time, if you think about, like, challenging or whatever, most of them just weren't challenging because they were just implementing a spec. So, um, some of them were researchy, Hackswave, um, Hex said it was finicky, but yeah, I don't think any of those really. Um,
Any new STB libraries on the horizon?
Probably not. I have some semi-finished ones and maybe even finished ones, but I don't really want to have to support more. Um, so one thing is that now that I quit Epic, I hopefully will be able to support the libraries better because I've been very, very slacking about it. Fabian Keeson, then it's Rigorous, RYG, has been doing he's a on GitHub, he's a co-maintainer, and he has been doing some of the, bringing, what do you call pull requests, merging pull requests. He's been doing that for the last couple of years because I've just been too burned out on it. So hopefully I'll be able to take that back up. But I was so burned out on it that I wasn't doing it at all. And so if I do start doing it now, I don't want to start adding more libraries and run the risk of
Yeah.
burning out. So I may just not releasing. I'd really like to kind of release the ones that I've done as like unsupported, but you can't really do that. Like A, you'll get support requests, and B, I philosophically am opposed to that. Like, I don't think it's healthy for the open source ecosystem for people to release unsupported stuff because basically I for there are a bunch of reasons, but here's an example of a reason. Let's say you have a problem you want to solve and you go look around and you find there are 3 libraries that do it. Well, which one do you pick? Well, it might turn out you pick the one that's not supported and doesn't actually work. Right, so you, like, have this challenge of, like, trying to figure out, well, is it really finished? Or does the person say it's finished, but it's buggy? So you're like, "Oh, do I have to look through all the issues and see what the status of it is?" Like, you're just adding friction to that person's work. If there is already a library out there that does it and does it well enough, like, don't release the unsupported library that also does it. Almost all of the, like, STB Orbis and STB Image are supporting stuff that's already out there. People could use the other libraries. People can use libjpeg and libpng and libvorbis, but they choose to use this because it's a little easier to use or easier to integrate or one of those things. I assume. I assume that's why they use it. And uh and so it's beholden on me to actually make that be true. If if they use it and it turns out there's a security hole in it and that matters to them, now I've hurt them. So I need to avoid that. And all of the SB libraries are bad about security because they were always intended for game developers not to be internet facing. But I never documented that very clearly. And so there's a problem there, and I don't quite know what to do about it because it's already kind of gotten established. But, like, for example, STB TrueType, just an oversight because I was just making it for my project and I wasn't really worried about, someone installing a bad, TrueType library because it was meant for a game developer who was using my whole big library, and this was a small part of it, and they would be supplying a real TrueType font of their own. Like, the TrueType API in FTP TrueType takes a pointer to a memory buffer that you've loaded the whole TrueType font into that memory buffer. I mean, TrueType is a compressed format, so loading the whole thing in it's no normal thing. But it takes a pointer to it, and it doesn't take a length. So it has no idea if you read off the end of the buffer. It
Okay.
can't know. Because if you give it a bogus, intentionally bad TrueType thing that tells it to read off the end of the buffer, it will. Because it has no idea, because I didn't put a length in. And I've never gone back and fixed that because I would need to actually fix all the code because none of the code is checking for that. Like, because I just didn't, like, it wasn't the part of the scenario. Now, the reality is actually, if you're shipping on a console, you actually do still want to care about security because people keep exploiting consoles by finding bugs in games and using them to, like, break this. Like, that's how people jailbreak consoles, and because consoles have all this crazy security to keep people from getting to put their own programs on it because basically it lets people copy games. It's the big reason why. And so one of the ways people exploit that is they find bugs in the programs and exploit those bugs. And so if people are shipping my UI library and it has a exploitable TrueType, so I shouldn't have done it that way, but I wasn't thinking about any of that stuff when I wrote the
Yeah.
library. And so the library just doesn't have any of that kind of error checking in it, and I don't want to go back through and add all of it to everything of that 5,000 lines of code. No thanks.
Yeah.
So it just has a big note at the top that it's totally unsafe.
Okay. That's one way to deal with it, with a big comment.
Yeah, well, just like now, there's a big comment at the top of the library, the GitHub repository itself. It says this project discusses security relevant bugs in public in GitHub issues and pull requests,
Okay.
because people keep trying to like say email me and say, "Oh, I've discovered a security bug in one of your libraries. I want to create what is there's a name for those
Pull
error."
request or
No, no,
issue.
yeah, no. There's security things, the
A
CV,
CVE. CVE.
CVE. People keep wanting to issue CVEs and stuff like that, and I'm like, so I kept having to reply to these people, and I finally just put that note on the repository that's like, we don't do this security stuff in secret. That's just not how it works. Sorry, like because we're not security focused. Like that's not was not the original intent. We have tried to get better about STB image. Fabian has done a lot of work with like making sure we don't overflow energy. Like he has crazy functions so that when we multiply numbers, we test whether the multiply would overflow. And if it would overflow, then we just bail, and stuff like that. So we've been working on improving the security of STB image, but only STB image. That's the only one we care about the security for
Okay.
because it's the one everyone uses. But
Yeah. All right. I have a lot of questions on for the opinion corner, for the closing segment.
sure.
Shall we start with it?
Yeah, I have some opinions that you don't have on your list, but maybe we'll take turns.
First of all, you started programming a long time ago, and you've seen how various companies operate. And you've now recently quit Epic, and you didn't like the bigger size of the company, but I'm assuming the bigger size impacted the way you had to work in some regard. How did the programming or programmer job changed over the years, at least looking from your eyes?
The problem is that I've only formally worked at 2 companies, 3 if you count Rad and Epic separately, then it's 3. So I don't have that many different experiences, and they're so overwhelmed by, like, the size of the company and the nature of the company. So I worked at LGS at Looking Glass, which was a game company. Uh, I worked at Rad, which was a quote unquote middleware company with 1 programmer per project. And then I worked at Epic on as part of the Unreal Engine team, technically, um, not on a game. Uh, but even at Epic, I was working very isolated from Unreal Engine. I was working on Rad stuff. Like for me personally, not for most of the other Rad employees, but for me personally, it was basically like I was still working at Rad. Like,
Yeah.
it really didn't directly impact me in the day-to-day programming. So I don't think I can tease apart the differences there as a time thing, like, in terms of I assume what you meant by your question was you're trying to address the larger question of how has programming changed from the '80s to the 2000s to the 2020s.
Yeah.
If that was what you meant as, like, a time thing, I don't think I can comment on that because my experiences were so specific to those specific jobs.
Okay. Okay. So from the company side, I say it's difficult to answer. Also, from the technology side, C, C++ changes, new standards, new fashion. Uh, because you had isolated type of work, I'm assuming you didn't really like engage in a lot of like object oriented,
Yeah,
extravaganza.
like we talked about it, like we made fun of it or whatever, because, I was definitely Jeff and I were both serious C programmers, but there were other people at the company doing C++ work. And, uh, we were certainly like, Casey is best friends with Jeff. And so Casey Muratori, who was famous for Handmade Hero and for educating a whole generation of programmers in this sort of low level I guess he writes C++, right? But this sort of C style thinking about problems, I guess you could say. And so I think I don't remember where I was going with that.
No, I mentioned object-oriented programming and generally speaking, the shifting trends in.
Yeah, yeah. And so yeah, I think I just have been very isolated from it and just able to do my own thing and not worry about it. And yeah, it hasn't appealed to me. Like that was the thing is I did learn C++, plus plus, and then I shifted away from C++ plus plus back to C because I felt like there were not enough benefits to C++ plus plus compared to the costs, the risks, the very hard to say. Like it's very like, there was a period in C++'s history where what was happening was everyone was subsetting C++. They were saying, "Well, let's not use templates, let's use this, this, and this." But every company was had a different subset that they were using. And that might mean, for example, that it would be a little harder to have transferable skills between 2 companies because you weren't as experienced in, the thing. Probably not that big an issue, and I don't think anyone talks about it that way anymore, but it's definitely, like, some weirdness there. Um, but yeah, the C spec itself has continued to change over time, but I don't think anything that's been added has been controversial, really.
Which one do
Like
you
most
use?
of it. I s- so I'm a very weird person who really hates upgrading. And so for example, I'm still using Windows 7. Uh, but that will have to change soon. For one thing, Steam stopped working on my Windows 7 machine like 6 months ago.
Oh,
Um, and let's see, uh but so yeah, so I still use VC6, Microsoft Visual Studio from 1998. Um, it's a single-threaded compiler. It doesn't compile multiple files at the same time. But all this work that I do is so small that it still compiles in like a full rebuild on anything I work on is still under 10 seconds or whatever. So it's not too big. And usually it's an incremental rebuild, so it's but, I use that because of the human factors, because of the user interface, just feels better to me. Like, at work, I've used the other ones, and they just don't quite feel as streamlined to me. And a long time ago, I used to use Vim, but not I never used Vim, I used the actual original VI. And I learned that, and I got used to it, and I was comfortable with it. I learned that in college, and I used it in DOS for a while, but eventually like, gosh, we didn't even talk about, like, Turbo Pascal and Turbo C, which is, what languages I learned over time, but, those were these IDE experiences, and eventually I decided, rather than editing in one thing and then compiling and debugging in a different thing, given that the IDEs had an editor, I should just start using the IDE editor and get used to it, and so I did. And so some people swear by the Emacs or the VI or I've forgotten all the DOS and Windows editors now. Reef. Reef was one for a while back then. And whatever the current ones are. Some people swear by that, and that's fine, but I had decided to embrace using the editor that's integrated with the debugger experience and just stick with that, and so I did. But then the later Visual Studios, like I said, the workflow just doesn't feel as streamlined to me as it does in VC6, so I stuck with VC6. It builds executables for an old it's optimizing for an old processor, but again, making indie games or whatever, it doesn't matter too much, and I can always break out a modern Visual Studio and compile a modern thing if I really need, uh, the the faster performance. It does also mean that I can't really use most people's libraries because most people's libraries don't build in VC6, uh, which is part of why there are so many SUB libraries because I have to make my own libraries.
okay. Okay. Yeah, with Steam stopping working, it seems like because Windows 7 for a long time doesn't have like official support, right?
Yeah, yeah,
Yeah.
they stopped supporting it many years ago, which is why apps have stopped supporting it. Steam announced they were stopping using it, like the Steam Windows said this will stop being supported on whatever it was, January 1st, whichever year it was. And for a year and a half after they hit that date. It showed that at the top, but kept working fine.
Okay.
Uh, and then finally it stopped. It hard hangs my machine now when I run it. I don't like it doesn't just crash. The whole machine dies. Epic. So the only actual game I play a lot is Rocket League, and I had Rocket League on Steam, which I paid for back in the day. But Rocket League got acquired by Epic a while back, and so I have this old Steam account, but I also have the Epic account. It's actually I have a different anyway. Um, so I can run Rocket League on the Epic Game Store, and that one works. So I have been able to keep playing Rocket League, nothing else for the last 6 months. However, recently the launching it was started crashing on the Epic Game Store.
Uh-oh.
But I discovered that it's because of the overlay. You know how Steam has an overlay?
Yeah.
Like it's that lets you, do various Steam stuff with it. So Epic has one too that I've never used. And it's some kind of DLL injection into your thing. Anyway, it turns out this Epic Game Store works fine, but the overlay is what's crashing. So I just go into the directory where the overlay is and delete them or rename them, and then it runs without the overlay. And every time Epic updates, I get a new copy of it and I have to go re-delete it. So yeah, that's what clearly at end of life. I really need to actually get a Windows 10 or 11 gaming machine set up. That is the plan. I was planning on doing it right away when I left Epic, but I had an injury and haven't. I needed to rearrange my apartment. I wanted to for various reasons, wanted to rearrange my apartment and was going to do that first. And then because of the injury, I couldn't rearrange my apartment. So after a month, I finally now have been able to rearrange my apartment, and I will get that Steam machine and Windows 10. So if we had done this like 2 weeks later, I probably would have been able to be on Windows 10 for this. But
Okay.
unfortunately, I didn't
Okay.
think of any of that when I scheduled this. So.
Um, and then what games will you play? Are there any games you're looking forward to?
Oh, I have so many because I barely like, I mean, I haven't played anything in the last 6 months, obviously, but also just like, I really didn't play that many games in the last 4 or 5 years. Um, and now that I'm free, I hope to actually play a lot. So, from the recent, there's like Blueprints. Um, I have a bunch of games on my desktop that I've never played. I might try to get XCOM and dig into that. I want to dig back and play there were a couple games that I couldn't play because they didn't run on Windows 7 that are now old, like, Forza Horizon, um, just a bunch of random different stuff, like, there's not an obvious single genre, like, uh
Did you play R did you remain RPG fan like Baldur's Gate 3 or some older ones?
I played some of I played Baldur's Gate 1 back in the day, and, when I started at Looking Glass, that in that era or whatever, I was playing games, and I played The Sims, but, yeah, the whole Ultima thing was definitely, like my friends wanted to play Ultima 7, so I played Ultima 7 with them. I didn't know anything about it, I hadn't played any of the earlier ones, whatever, and the Ultima Underworld was amazing because it was a Looking Glass game, not because of the Ultima connection. So RPG hasn't really been a thing that I've been
Okay.
super tied to. Like I said, I did play Baldur's Gate and I played Planescape Torment,
Yeah.
but I never got into like Mass Effect or any of the Bethesda games. I could try this Obsidian, I think, but I didn't enjoy it.
Okay. On the other note, did you try any of the new systems slash low level programming
I have
languages?
not tried any of them. Part of that is because I am the stick in the mud who doesn't want to change. Part of it is just because, I had too much else to do. Um, I think if I had to try it, I might do Jai. Like Odin and Zig don't really speak to me that much. Yeah, they all seem like reasonable things. I don't think there's anything wrong with them exactly. In fact, I do think there's something wrong with Jai, which I'll say in a second. But I had this weird experience in 2003, maybe. I said, I think there are a bunch of programming things that could improve my life. Like, ML has type inference where you don't specify the types of things, but you still get static type checking, right? Like in Python, you don't have to specify the type of things, but you might not get the error until way too late. So you want static type checking to avoid that. Um, but type inference, which is like auto in C++, um, in ML, it's a very fully realized thing where almost never do you have to give type info, or maybe never, in true ML. There but unfortunately, because of that, there's weird things like plus only operates on ints, and there's a different operator for adding floats so that it can know that the inputs are floats or ints. So there's some things that are kind of complicated. So I was thinking that a language that had type inference, but you could specify types and it would approach the problem a little differently from how ML approaches it, more flexibly. And maybe garbage collection might be a nice spot to go for making things like small programs, not for making games. Like Jai is aimed at, I want to make a game. So I want like all this stuff. And I was thinking more about like, I just want to make a little quick and dirty program to do something. What are the things that could accelerate that operation? But as you might know, if you've heard of my talk about writing small programs in C, what happened is I started developing that language. I got a ways into developing that language. I think I wasn't compiling to native code. I think I was compiling to C. Um, but I got a ways into it, and then I started doing the stb.h. And in stb.h, I had the dynamic array thing. So the whole point of the dynamic array is it's just what like lists in Python or vector in C++. It's an array that you can append to that you don't have to statically decide its size. And in C, you can do that with malloc and realloc, but you have to manually keep track of the size. And it's not fun. And so the dynamic array thing that I came up with for stb.h and stretchy buffer and stbds is a sort of type safe thing where you're because you can make macros and wrap this, but it's ugly. If you're either you have to use casts or you have to define a new macro for every type, or you have to pass the type in. Um, so the whole thing about this data type is it lets C look like it's the C++ thing. It lets you say you have a char star and that's actually a dynamic array and you can push chars on the end of it. And it's all done with macros and there's some trickery to how that works. Doesn't matter. The whole point is that it's convenient. And so the whole thing was that I had gone down this avenue of thinking about this language and started programming it. And then I started coming up with these ideas for stb.h and discovered that I could do dynamic arrays in a syntactically convenient and type safe way. And I could do hash tables. And I found that if I started writing small programs and I had dynamic arrays and I had hash tables, like string hash and like a hash, a pointer to a pointer or something, I could define generic ones, but it was a mess to do. But just having those was enough that suddenly almost all small programs that I wanted to write were pretty easy. And like from data structure perspective, that's all I needed. Then there's like helpers like load a file into memory and stuff like that, which are again were in stb.h. And so once I started having all of those, I suddenly found I didn't really feel a need for that language that I had started doing. And so, and that's what that writing small programs is about, was A, you can do this thing that I've done, and B, there are some other things you can think about. But the whole point of all that is that so there are two scenarios. There's writing small programs and there's like writing a whole game or whatever, which is where you want the low level stuff, like when the low level makes sense. Um, but I don't do that much of the low level stuff. I make indie games, and the indie games, like you have 10 objects per level. You don't have 100,000 most of the time. Um, so the demands or the performance demands just aren't that high. And so it's more a question of the convenience of programming, and C just works well enough for me that it's not really been an issue. So the Jai thing for me, the biggest problem I have with Jai is that Lisp had a thing that's called Lisp macros. Um, and one of the problems that came up with Lisp macros is everyone would define their own macros, and the macros can run at compile time and parse what's coming in. and everyone defined their own list macros, and nobody could understand anybody else's code. And you didn't even know what the code would do when you looked at it because you didn't know what macros would do. And Jai, because of its compile time facilities, I worry could go down that path. Now, John doesn't want it to go down that path and, is trying to keep what he puts at compile time sane. But if it actually became a language out there in an ecosystem, I worry that you might have people start abusing that.
Yeah, currently in the beta, there are people that are trying to abuse that. I mean, just kind of for the sake of
For fun, yeah.
activity
To
to
see what you can do, yeah.
yeah, yeah, yeah.
Which is fine, but
But
there's a very famous Watt programming talk where the guy goes through JavaScript and Ruby and shows some weird things, and then shows a crazy meme that says Watt. And that's one of the examples he says is Ruby doesn't support bare words, which means typing out just raw text and it becomes a string because it's like, I can't parse it as anything else. It's a string. He's like, Ruby doesn't support bare words, but if you type in this program, Ruby supports bare words. And that's awesome. And it's a meme of a Tyrannosaurus Rex playing the drums. But if you ever ship a program that does it, what? Um, and that's exactly the Jai thing. Like, it makes perfect sense to like, let's see what crazy things we can do for fun. Go ahead, the Tyrannosaurus Rex playing the drums. Just don't ever ship it to anyone.
yeah. Um, are you working or were you working in the past on the C compiler?
Yeah, so the C compiler is something I was doing at RAD. Um, I don't remember the 100% the motivation for it. Like, we had stopped working on, we had ended the project I'd been working on before. And I think, I don't know to what extent it was like a sop of Jeff, like giving me something to do that I liked and how much it was something he desperately wanted, but it was definitely something he wanted because the pitch was that we can't trust compilers because they keep adding exploitations of undefined behavior, which is legit according to the spec. But the problem is that the spec is like very unclear, not written for an average user. And so a lot of undefined behaviors were not clear that they were undefined behaviors and were not effectively undefined behaviors for a long time and were things that people were doing for a long time. So for the one of the big ones that happened was like casting between int and pointers. You could just cast them and it worked. But at some point they decided that was illegal and you had to go through a union convert between the two. And if you didn't go through the union, it would break. And that was, according to them, that was how it always was in the spec. It just happened to work. For so the reality of that in a certain class of ours perspective is that what it really was the de facto standard, and the de facto being Latin. And the de facto standard was what everyone thought the standard was, what all the actual acting programmers thought the contract that they had with the compiler writers was. And at some point, the compiler writer said, well, the contract should be the spec, and the spec lets us do these other things, and that lets us optimize a little more, and that lets us improve our spec mark and say we're a better compiler. So we're going to do that. And screw you, programmers. And like, I can't say that they were 100% wrong to do that, but the reality was the spec was way too complicated, and that's not what anyone targeted. What everyone targeted was the de facto spec that said you could cast between floats in it and not floats and integers, between pointers and integers. And they're like, that was, everyone knew you could do it, so everyone did it. Anyway, so one of the points of the C compiler was I would write a C compiler that we knew what was acceptable and it wouldn't make crazy optimization trade-offs for undefined behaviors. Because for a while, people weren't clear whether the union for switching between pointers and integers was valid. There was a whole language lawyer cycle where people were like, oh, I think actually the union way isn't valid. You have to do this other even crazier thing, which I can't even remember what it was. Or maybe it was impossible. Gosh, I don't even remember. I think they pulled back from it and people decide, no, it's actually valid by the spec. But no, that was just a whole nightmare. And we were like, this seems crazy. Let's and I was like, I think I could write a C compiler. We could just get around that we'll just write a C compiler. There was another thing which was that there was a pitch for something called Friendly C by one of the C gurus that was like basically his idea was this would be a compiler for old code because the old code had these wrong assumptions. And instead of trying to fix the old code, let's just define this new de facto C standard and have that compiler for that. And then he backed off the pitch because everyone disagreed about what were the things in the original thing. Understandably. So one of our ideas there was that we were making our own personal friendly C compiler that did what we expected it to do, and we would target it. And so I worked on that for a while. Um, I got a functioning C preprocessor, and I had a lot of the parser and not much else. The parser and like generating an AST. And then Oodle was a success, and uh like people started using Oodle. And so I got pulled off that project and started working on Oodle to help Oodle because Oodle was like, you know, the PS5 or whichever one it is, they added the Kraken compressor, which was out of Oodle's. It was the Oodle compressor. Like that's how successful it was. Everyone loved it. And it was a pretty good compressor. And all of our customers loved it. And they loved it so much that Sony said, let's put it into the hardware. Um, Make an actual hardware implementation of it. So yeah, like I don't think that was the wrong call to go off the C compiler and start working on Noodle. But that just meant the C compiler died at that point. Um, the C preprocessor eventually got resurrected and used at Epic to preprocess shaders, because a lot of the shader languages support preprocessor stuff. And of course, when you feed it to the shader compiler, it will run the preprocessor. But Epic wanted to preprocess shaders themselves. I think it's for deduping, so that you want to see, are these two shaders the same after preprocessing? So you need to run them through the preprocessor. So I think that's what it ended up getting used for.
Okay. Okay. So there are no plans to revive C compiler in your spare time
No,
now. Okay.
no.
Okay. But there are plans for
Yeah, I guess
music, right?
yeah, when I quit, I said I plan to make music and play games. And then like I said, that injury prevented me from
Okay.
reorganizing my apartment. And the music has been waiting on me to reorganize my apartment. Because the whole thing is I have a 2-bedroom apartment with a small bedroom and a large master bedroom. And the large master bedroom I turned into a music room several years ago. And then I think it was COVID happened. And I started working from home. And so I started piling junk up in the music room, and I never actually used it as a music room. I've always been making music, but that room had originally been both music and other computer stuff or whatever. And so I had refurbished it. So it was just music stuff. I put a bunch of posters on the walls that were all music posters. So I was like, this will be a place where I make music and I like can focus on music, and I'll put my gaming computer in a different room. And then I think COVID happened. Something happened, and I just never literally stopped making music. I had been making music before that, but not, as often as I'd like. And then I set it up so I could really do music, and then never used it. So yeah, I'm finally now starting to rearrange the apartment back so that this big, spacious master bedroom is just a music room. It will be wonderful, and I will start making music. So I'm looking forward to it. Um,
You play
but
guitar?
guitar is my real instrument. I play guitar, I play bass, I play keyboards badly, I play the drums, uh, a little better
Yeah.
than badly, but not like awesomely. I have an electronic drum kit, so because I live in an apartment, so I can't be noisy. Electronic drums are quiet, if you get the right kind of electronic drums. So I have an electronic drum kit that I haven't played in 6 or 7 years. It's all packed up. Um, so yeah, maybe I'll break that back out and play it. Maybe not. Like it's fun. Drums are very fun to play, but if I just program the drums instead of playing them, it's better. Like I'm just not a good enough drummer. My timing is inconsistent. So I'm better off just programming the drums anyway. So while I enjoy playing the drums, if I actually want to make music, I probably won't use the drums anyway.
Okay. Okay. Look, I think we're
No,
coming.
I had my opinions that I wanted
Yes,
to
this
tell
is what
tonight.
I wanted
Let me give my opinions.
to
Okay. I thought
open
you
the
were not wrapping
section.
up.
Yeah.
Yeah. So this is a response, or not a response. It's not a criticism, but some of the recent podcasts, certain things have been said that I had comments. Again, I'm not criticizing anything anybody said on those
Okay.
things. It's just added information. It's context.
Okay.
So Somebody was talking about how React is really neat, because it does this thing of you kind of get an immediate mode out of a retained mode. I don't remember how they described it, but the whole idea that you in React, it's React, right? That you do this. There you build what you want your DOM to be, and it takes the current DOM and what you want it to be and figures out the delta to convert between it. Because if you just said use this DOM, the browser would be super inefficient. Instead, you like delta between it. Does this ring a bell?
Yes,
You know what
is
I'm
this
talking about?
in the Nick Barker episode with
Yeah.
Nick Barker? Yeah.
So I just wanted to highlight that it's super great that React does that. Super awesome, smart to do that. Original idea to do that with the DOM, but it is not an original idea. That's
Okay.
again not a criticism. I'm not saying he said it was. But I just it's an interesting historical thing. So going way back, you had mainframes or mini computers with terminals attached to them. So in my high school, we had 4 CRTs and 4 printer terminals. Believe this or not, this is an actual thing that existed. You hooked a printer up, a printer terminal up to a thing, and the output just came out on the printer and scrolled up. You would type in your program, and then you would run it, and this just got all kept coming up on the printer.
Okay.
Crazy. But it's also very slow. So the CRTs were what you wanted, but the CRTs were there were only a few of them. So it's hard to get on the CRTs. Anyway, so the CRTs, of course, mostly did the same thing. You would get text back from the mainframe and it would put it at the bottom and scroll up. But smart terminals existed, and smart terminals like the VT100 accepted a sequence of control characters that would move the cursor around different places on the screen, not just keep adding to the bottom. So you could move the cursor to somewhere on the screen and change one character. And there was actually a command sequence that meant delete all the characters to the right of this point. Not delete all, delete one character and move all the other characters over. So rather than transmitting all of that stuff, you could just say delete one character and it would shift the line over. So if you want to write a text editor, and in the text editor, you want to be able to delete a single character, you have a memory buffer that stores what your characters are, and you delete one character. And then you also transmit the thing of move the cursor to that spot and delete one character. Okay, that doesn't scale very well because it turns out there are like hundreds of terminal types. And Unix famously has a file called termcap, which stands for terminal capabilities, which has a list of all the control codes for each terminal. But not all terminals have the same capabilities. Maybe one can delete from a single character and shift everything over, but another can't. So you need what you want is some way to solve that problem. And you have even if you didn't have that problem, even if you just had the VT100 and that was the only one you handled, you would have this problem that you're doing everything twice. You're deleting a character from the memory and shifting the memory over, and you're sending the code to transmit the thing over. And if you're doing everything twice in code, everything is written twice, there's a easy chance that you'll get out of sync, that one of them will be wrong or whatever. So what you'd like to do is A, solve all of those different terminals at the same time, and B, only have to write the code one way. So there's a library in Unix called curses. And what curses is it's for text only. And you draw a screen, you make a memory buffer. I don't remember what the interface is, but you make, a memory description of what your 24 by 80 screen should look like. And you hand it to curses, and curses says, what is the delta that I can transmit with control codes to this terminal of this type? That's the minimal bandwidth, the fewest characters that I can send that will convert the current screen to the screen that they just requested, which is not identical to the DOM thing but it's basically exactly the same as the DOM thing. So, and it's for kind of a similar reason. But in this case, it's the bandwidth of your 300 baud connection to your terminal or whatever, but it's for performance reasons. Um, and so it's just an interesting pattern. And I just wanted to point out that, there were smart people working in the 70s. Like a lot of these problems have analogs that have been solved and now forgotten. Um, And I did program curses. I participated in something called the International Obfuscated C Code Contest, and none of my winning entries, I don't think, used curses, but I did submit some entries that used curses to I made like a video game that used curses.
Okay.
Um, so that was one of my comments, just, not a criticism, just
Okay.
like, React is not 100, just so you know, React they may have reinvented it without knowing about curses, but,
All right.
um,
What's the next on the list?
I think I only have one more, but,
Okay.
so I think a different person commented that the C decision to use null terminated strings was terrible.
Oh, oh.
Does that ring a bell? Do you remember
Mm,
hearing that somebody had the opinion that C made a mistake in having null terminated strings? I
so one person who was disliking C was Ginger Bill, who made Odin
No, it
programming
was one
language
of the recent ones. It was the other most recent one. Uh,
with Anton.
yeah, I think so.
Okay,
It
it
was just
might be.
it was just like he was like it's a criticism. It's like C has some
Okay,
mistakes,
okay,
and one of the
okay.
mistakes was they had null terminated strings. And I can understand why you would think null terminated strings are bad. You don't get a length, so it's a pain in the ass to work with. But I just want to mention that there is a reason for it. Like, it's not just crazy, well, we've saved the memory. Because, like, sometimes people think, well, because like the early Macs had a format where they stored strings and the first byte was a length. I think some versions of Pascal did this too. But then you were limited to only 255 long strings, right? Like, that's not great. And like storing a whole D word or something at the beginning is kind of gross. Whereas if you null terminate, it only costs you 1 byte. It's at the end, not at the beginning. So, like, some people think that that's the reason for it. And I don't know. I'm not an expert in the history of the development of C, so I don't know what the reason for it is. But I do know what the experience for it is, and that is that um, parsing, in the sense of iterating linearly through a string and doing different things depending on what you encounter, is super good with null terminated strings. And that is what most people were doing with strings most of the time. So I will
Okay.
be specific about that. So in Jai, there's like array slicing or something. I don't remember exactly what it's called. But so in Jai, you can take an array and you can kind of iterate through it and pass in the where you currently are in the array. And what it does is it has to pass in the start point of the array, the current point, and the size of the array, because you can still dynamically extend it or something. I don't remember exactly, but Jai has some functionality where it just passes in those three values under the hood. It looks like one variable, but it's actually all three values. C, and that's what you need to do uh non-null terminated string parsing. Like, if you want to have an iterative thing where you're pointing into the middle of the string and the string has a length, you either need to pass in the length that remains, or more accurately, you pass in the start of the string and the full length of the string and the current point that you're at. Like, that's what makes sense. But C was designed for these old, slow machines with not many registers. You weren't going to pass 3 D words in to for every string. You passed one. And that one is a pointer into the middle of the string, which is null terminated. So if what you're doing is that kind of iterative walk and you're on a modern machine, you can do what Jai does and embrace it and go, yeah, we'll just pass in 3 values under the hood. It works. It's not that expensive because you have 16 registers or 32 registers or whatever you have on a modern machine. It's not free, but it's not like the end of the world. And on the machines that C was on in those days, no, it made way more sense that you passed in one thing, you had null termination, and it let you iteratively walk down the array. And they only did that for, I mean, they didn't have length arrays at all, but they only did that for strings. They didn't do that for arbitrary arrays. If you wanted to just make an array of ints, you weren't expected to put a 0 at the end or what, like, you were expected to have a length and keep track of it yourself. Annoying, absolutely. But like, it wasn't normal. It was only for strings. And that's because strings were used in a certain way most of the time.
Okay. I
That's
did.
my opinion about it.
Okay.
So that was, yeah, I just wanted to raise that because people understandably reject null terminated strings as seeming like a dumb idea. And I feel like it wasn't a dumb idea. It was an idea that made sense at the time.
Yeah.
In a similar way, actually, he mentioned that header files are terrible, and they are terrible. Like, I don't like header files. I mean, I rely on them for my most famous project. Like, that whole idea is dumb, except if you're going to use C macros, header files is like the way you gotta do it. Because normally what you want to do is replace header files with modules that somehow share declarations across or whatever. But macros really need to work with text. And so like trying to share macros across modules, like header files just makes way more sense for doing it. Again, I actually agree. Header files are not great, but there's kind of a reason for them why they're still sticking around. And one of those reasons, at least, is macros. Um, and then just another thing to know about C is I don't think is a response. Maybe it's a response to him as well, but I don't think it is. One thing to know about C is that it was the first cross-platform language. Like there was like Pascal or something else before it, but like it was the first one deployed in anger, like in practical use. And so like I'm not saying like therefore it's justified to use it nowadays because of that. It's just a thing to understand about its history, about why it is the way it is in some ways, is just that it was meant to be cross-platform. It required if defs on a lot of things, which is not great cross-platform. That's like if you in Python had to, well, you do with Windows versus Linux, but most of the time in Python, you don't need to conditionally do stuff. Clearly it wasn't the greatest cross-platform thing, but it was way better than assembly language, obviously. And like Fortran, you couldn't do low level. So like Fortran was probably already the real cross-platform language, but it wasn't the systems language. So, you had to if-def stuff because of platform differences and potentially if-def stuff because 8-bit bytes versus 9-bit bytes or whatever insanity that was. But at least you could do it, like, people did do it. People ship and that's part of why probably has led historically to now we get this case where everyone makes their library C so that they can be reused by all other libraries, is because it's, the lingua
Yeah.
franca, it's the thing that has the stable ABI that everyone can trust and use, and so all the other languages can make use of it, and, part of that is because it was successful at being a cross-platform language. So, it's just a thing to know about C. Again, it's like, that's not even point. Like, it's just like, I think that matters in some way. I don't even know how to articulate it.
Mm.
I think that's all I have. I mean, other than stuff I skipped because who cares?
So there was more. Okay.
Well, I'm looking over my notes. I think we hit everything. Multipass, I am GUI, no. That's fine to skip. We talked about that. My crazy syntax highlighting, we don't need to talk about. Uh, I am GUI.
What you said you're using VS6 and you
Yeah.
do this, do you have the Vim plugin, like Vim key binding,
No, so I don't use
Vim
Vim. I
motions?
learned the whole thing is that I learned to use back before VS6. I switched. I stopped using Vim and I switched to just using the
Okay.
IDE's editor, the whatever the default Microsoft editor is. I was just like, I'm going to learn to use that and get comfortable using that because then I just always have it in the IDE.
Okay. You don't install the plugin for the Vim motions to have like inside VS Visual Studio, you have like your Vim
No,
shortcuts.
because one of the things is that like one of the things that I liked was that I could go to someone else's machine and like they needed help debugging something, so they'd be in the IDE, and so then I could reliably type and not be expecting a plugin or whatever. I That's like kind of a general philosophy that I have. I don't really like relying on external stuff. Like another example of that uh, comes up a lot is uh, can't remember the exact formulation of this. People have things where they're like, well, this aspect of the language design, I'm sorry, I'm just talking so abstractly. This aspect of the language design is perfectly reasonable because in the IDE dedicated to this language, it
Okay.
automatically can expand and work for you. And I'm like, okay, but what if I'm just browsing it on GitHub? Then I can't do that and I can't collapse the thing or, the whatever. And so, it's more than, it's not syntax highlighting. It's a very specific syntax highlighting you do get on GitHub or whatever. But so I can't remember what the examples of this were, but I've definitely encountered this philosophy of like, oh, as long as you have the extra tooling, it's all fine. And I'm like, but what about when you don't have the extra tooling? And maybe most people, that's fine. They always have the extra tooling. But I've been burned by like that experience with the Windows libraries not having a home. Like I've I've developed a habit of don't make me deal with something where there's an optional thing because I'll end up in a situation where I don't have the optional thing. And if the UI flow, workflow, understandability is not good without the optional thing, to me, that's a problem.
Okay. Okay. We talked a little bit about your future in terms of making music and playing games. Do you have any
Yes.
plans for indie game development or professional work, or not for the
Right.
time being?
Yeah. So like right. That was very explicitly the blue sky tweet was, I don't know what I'm going to do long term, but in the short term, I'm going to make music and play games. That's definitely not my long term plan, but I didn't have a long term plan. And part of that is because I know from experience of from 2001 to 2008 that I failed as an indie game developer, but I can't expect myself to be successful. So I'll probably try it and I'll probably fail at it. I might be able to make some small games again. That'll be free. But if I try to make anything commercial, I have suspicion that I'll never get it done. I do have 3 or 4 ideas, some of them that I had already at Rad and some that are new, um, that I'd like to make, but I don't know that I would ever finish them. I've already started playing around a little bit with some of them, um, because I hadn't reorganized my room, so I couldn't start on all these other things, but I could s I was injured, so I didn't it was uncomfortable to type, but I could go like 5 or 10 minutes, and then I would start feeling uncomfortable, so I would, like, just program a little bit just for, you know so I have written a little bit of code here and there and some stuff, but it is really unknown. I don't know what the future holds. I can't picture going to work for a game company, so
Okay.
it's indie games or nothing probably.
Okay. Okay. And so where can people follow your work? Do you post on Blue Sky?
I post regularly on Blue Sky, but unfortunately on Blue Sky, you cannot turn off retweets for individual users. So if you follow me on Blue Sky, you will see my political opinion an awful lot. Uh, and obviously there's my GitHub, and I think that's it. I have a YouTube channel that I have not updated in a long time. There was a whole period when I was posting a voxel. Oh my gosh, we never talked about all
Oh
my
yeah,
looking
that's
glass
true.
my looking glass voxel research or my voxel game YouTube stream or my reset compute shader voxel stuff. But I think we'll just move on. I think we'll live without that.
Okay. Okay.
I mean, I'm happy to do it, but it's got to be late there. So
Yeah, it's 30 minutes after midnight. So
yeah.
you already broke the record for the longest one. It's gonna be close to 5 hours, by the way. So we'll see. It's probably 4 hours 30 minutes gonna be the episode. So it's gonna be the
You think
longest.
you're not gonna cut it all out,
I'm gonna cut some parts, like starting and ending and like
but
stuff.
you're not gonna cut it down to 2 hours.
No, 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 no. It's gonna be like,
You think it's mostly good.
yeah, it's gonna be like an hour longer than the second longest. So it's not only like, it's not like I barely made it. It's like an hour
And
more.
there's so much we cut. I mean, so much we skipped.
Yeah. I've rewatched recently your discussion with Sean McGrath about like
Mhm.
a podcast discussion. It was a nice one, and it was also like you were working so much with the tech to actually have both of your video and his video.
Yeah.
It's like a small video and this video. It's like all sorts of
Yeah, I had no
nice.
idea how to do it. So yeah,
Yeah.
I'm glad that you've come up with
If
multiple solutions to this.
But still, I would like to hear a new podcast between you and Sean McGrath to discuss that.
Unfortunately, he I have always said yes, and he has never followed up on it. So I'm afraid it pressure is on him.
Okay,
Uh,
okay.
I don't know why he failed on it. But
He says that he cannot find the time right now, but eventually he will come to this show. So maybe I'll
oh,
ask him,
good. Yeah, you'll have
and
to let me
maybe
know.
I will connect you. You too.
Yeah, sounds good.
Right, Sean, thank you so much. This was such a nice discussion.
Oh, you're a very good interviewer, or I don't know if you're good, but I don't want to say that too negatively. I don't know if that's good as the interviewer. What's good is that you're interested in the stuff and you actually care about it. And you're like, it's very clear that you're interested in this, like the crazy old technology. That's all irrelevant now, but you find it interesting and that's
Yeah.
enjoyable to talk to you about it.
Yeah, it's awesome. I find it awesome. I find this passion awesome, by the way. Like, it's weird because, like, I didn't live in the time when you were starting out,
Absolutely.
but it almost feels like nostalgia when you hear you talk, or Sean McGrath, or Jonathan Blow, or Casey Muratori, or Mike Brash, like, or John Carmack. Like, when you describe how innovative innovative this stuff was and how this work looked like, it looked like inventors in one room trying to figure stuff out. It's much less so today in the world of programming in general.
What's funny is that I always felt like I missed my chance, that like 10 years before I started is when all the real innovation was happening, and I wish I could have been back then. One of the projects, off the record, one of the
This
projects
is
that I
wait, if it's off the record, then
okay, yeah,
let me say officially
okay, yeah.
very thank you so much for joining me, and
Thank
it was
you.
a lovely discussion.
I'm very glad we had this discussion.